Hello, good afternoon. Welcome to class 13. Today we're going to study emerging technology and computers. We'll just start in another minute. Right, just give me a minute and we'll start in a minute. First question is, can you see and hear me? Is everything audible, visible? Today is the last day I'm doing a class like this. From tomorrow I'll be back in the studio. So just right now, could you tell me if you can see and hear me? Good afternoon, all of you. Yes, Asha, it's fine. Thank you for asking. Okay, Santosh, Yamini, Sheetal, Nikhil, Pranjal, Ekta. Okay, so that's fine. I think you can see and hear me. Good. So today we are going to discuss emerging technology and computers. देखो, इसमें ना the questions that are asked, they are mostly application based. So they would ask you to apply your knowledge, and sometimes also they asked you the concepts behind how things work. And of course, to know the application, you need to know the concepts, right? तो अब हम क्या करेंगे आज? I would request you कि I'm giving you 1 minute. Please get a notebook or something to write on. ठीक है? Doesn't have to be like exactly a notebook only. Just anything to write on. Although every information is there in the slide, I'm not going to write anything new. But since a lot of concepts have to be explained, it would be better अगर आप एक notebook साथ में रखें, and then you are also writing down things that I'm explaining to you. तो वो please आप कर लो. So that's just an idea. If you could just get that in a minute, that would be great. Right? All right. So just get a notebook. हम पहले start करेंगे with quantum computing. ठीक है? देखो, इन चीज़ों को समझना मुश्किल है. Let me just be very frank with you. It's not going to be easy to understand all of this. So it is going to be tough, but the good thing is that we don't have to understand beyond a certain depth. We just have to get an idea. Okay, so please get a notebook. I'm just waiting for 1 minute and then we'll start. ओके, सो लेट्स स्टार्ट. देखो, सबसे पहले हमें पढ़ना है क्वांटम कंप्यूटिंग. ओके, क्वांटम कंप्यूटिंग में देखो यार, वी हैव ऑलरेडी रेड क्वांटम इफेक्ट्स. दिस वी हैव रेड इन टर्म्स ऑफ नैनोटेक, राइट? क्वांटम इफेक्ट, क्वांटम बेसिकली इज द वर्ड दैट गिव्स डेरिवेशन टू द वर्ड क्वांटिटी, राइट? तो हमने पढ़ा था कि अगर क्वांटम, like if the quantity is less, if we go to 10 raised to power minus 9, there are certain new effects that emerge that we had read in terms of quantum effects, right? And quantum scale would be atomic level scale. कौन सा scale? 10 raised to power minus 9, right? Okay, तो अब हम क्या हो रहा है, what is happening यहाँ पे, क्यों कुछ special effects आते हैं at 10 raised to power minus 9? ये नैनोटेक में भी हमने देखा था कि कुछ स्पेशल इफेक्ट्स आ रहे थे, राइट? स्पेशल इफेक्ट्स आने का एक मेजर रीजन ये है दैट एट द क्वांटम लेवल, जब हम इस स्टेज पे पहुंच जाते हैं, बिल्कुल ही एटॉमिक लेवल पे 10 रेज़ टू पावर माइनस 9 पे, जो क्लासिकल फिजिक्स है और मैकेनिक्स है, उनके लॉज अप्लाई नहीं होते. नाउ व्हाट इज क्लासिकल फिजिक्स एंड मैकेनिक्स? क्लासिकल फिजिक्स एंड मैकेनिक्स इज व्हाट वी डू इन आवर एवरीडे लाइफ्स. जैसे seeing a car drive on the road, right? This is classical physics. The earth rotating, this is classical physics, राइट, जो बड़ी चीजें हैं, बिग थिंग्स दैट वी सी इन एवरीडे लाइफ, दैट इज क्लासिकल फिजिक्स. बट जब हम क्वांटम लेवल पे चले जाते हैं तो इसके जो लॉज हैं, जैसे कि न्यूटन के 3 लॉज, राइट, इसके लॉज अप्लाई नहीं होते एट द क्वांटम लेवल and they generate certain special effects. This we had seen in nanotech also, right? So what is quantum computing? Quantum computing is basically that you use the theories that apply on this quantum level to in the idea of computing. मतलब computers बनाने में या computer technology develop करने में quantum level पे जो special effects होते हैं उनको यूज करके आप कंप्यूटर बनाओ. सो द कंप्यूटर विल हैव सर्टेन स्पेशल प्रॉपर्टीज दैट आर नॉट देयर इन अदर कंप्यूटर्स दैट आर वर्किंग ऑन द आइडियाज ऑफ क्लासिकल फिजिक्स. ठीक है, दिस इज बेसिकली द डेफिनेशन ऑफ क्वांटम कंप्यूटिंग. ओके, नाउ लेट अस सी व्हाट दी स्पेशल इफेक्ट्स आर एंड हाउ दे हेल्प इन वर्किंग ऑफ अ कंप्यूटर. ओके, ऑलराइट. बिफोर वी अंडरस्टैंड हाउ क्वांटम कंप्यूटर विल बी डिफरेंट, पहले हम समझते हैं हाउ अ नॉर्मल कंप्यूटर वर्क्स. मेरे सामने जैसे जो लैपटॉप है या जो आपके सामने जो कंप्यूटर है, इट हैज बेसिकली 2 स्टेट्स, राइट. फर्स्ट स्टेट इज के वायर से इलेक्ट्रिसिटी आ रही है, सेकंड स्टेट इज वायर से इलेक्ट्रिसिटी नहीं आ रही, राइट. दिस इज ऑल द कंप्यूटर अंडरस्टैंड्स. ठीक है, उसे और कुछ नहीं समझ आता. इट ओनली अंडरस्टैंड्स कि या तो वायर में इलेक्ट्रिसिटी है या नहीं है. आप जब टाइप करते हो तो देयर इज अ सीरीज ऑफ चेंजेस. पहले 0.001 मिली सेकेंड के लिए इलेक्ट्रिसिटी है, फिर नहीं है, फिर है, फिर नहीं है, समथिंग लाइक दैट हैपेंस. सो द कंप्यूटर ओनली अंडरस्टैंड्स थिंग्स इन टर्म्स ऑफ 1 और 0. 1 मीनिंग दैट देयर इज लाइट और देयर इज इलेक्ट्रिसिटी इन द वायर, एंड 0 मीनिंग देयर इज नो इलेक्ट्रिसिटी इन द वायर. सो दिस 1 and 0, this basic smallest part of information that a computer understands is called a bit, right? bit से बनता है byte, byte से बनते हैं then kilobytes, then megabytes, gigabytes. ठीक है, but this is what a computer understands. जो इसका सबसे basic unit है वो या तो 0 है या 1 है, and this is why it's called binary. अगर आपने कोई साइंस की टीवी सीरीज या बिग बैंग थ्योरी फॉर एग्जांपल या कुछ भी अगर आपने ऐसा देखा हो तो आपने बहुत बार ये रेफरेंस सुना होगा टू बाइनरी कोड, लाइक 100100001, समथिंग लाइक दिस, राइट. तो दिस इज ओनली व्हाट द कंप्यूटर अंडरस्टैंड्स. लेट्स से इफ आई टाइप इनटू द कंप्यूटर 16, राइट, द कंप्यूटर विल अंडरस्टैंड दिस. ओके, and then this is what the computer will understand, and then on the screen it will display 60. okay, तो कंप्यूटर सिर्फ ये समझता है कि या तो लाइट आ रही है वायर से या नहीं आ रही. इट कैन नॉट प्रोसेस योर लैंग्वेज, राइट. व्हेन इट स्टार्ट्स प्रोसेसिंग योर लैंग्वेज इट बिकम्स AI, वो हम कल देखेंगे. बट इट कैन नॉट प्रोसेस योर लैंग्वेज, आपकी लैंग्वेज को प्रोसेस नहीं कर सकता वो. इट कैन ओनली प्रोसेस व्हाट यू राइट. ओके, सो बाइनरी कोड either 1 or 0. okay, now quantum computers are slightly different, right? Rather than using bits, which was the normal code of 0 and 1, they have started using something called quantum bits or qubits, right? And what can they do? They can simultaneously represent both 0 and 1. ये चीज हम अभी देखते हैं, no need to understand here. पहले आप मुझे एक बात बताओ, या चलो let's understand this first. क्वांटम कंप्यूटिंग में देयर आर 2 प्रिंसिपल्स. ठीक है, देयर आर बेसिकली 2 प्रिंसिपल्स जो डिफरेंट है फ्रॉम अ नॉर्मल कंप्यूटर, राइट. नॉर्मल कंप्यूटर में क्या है, बाइनरी है, या तो 0 या 1, इसके टर्म्स में वो सब कुछ समझेगा. क्वांटम कंप्यूटर में 2 प्रिंसिपल्स हैं दैट आर डिफरेंट. द फर्स्ट प्रिंसिपल इज कॉल्ड सुपरपोजिशन, द सेकंड वन इज कॉल्ड एंटैंगलमेंट. ओके, सुपरपोजिशन एंड एंटैंगलमेंट. अब इन दोनों टर्म्स को हम डिटेल में समझते हैं, इनको हम डिटेल में समझते हैं. What does superposition mean and what does entanglement mean? ठीक है, ओके, यहां तक आई होप क्लियर है. अब मैं आपको एक थॉट एक्सपेरिमेंट समझाता हूं. देखो, बिफोर वी गो टू दिस वट एवर ये जो तामझाम है इसमें हम जाएं, इससे पहले लेट मी एक्सप्लेन टू यू कि इस वर्ड का मीनिंग सुपरपोजिशन, इट इज केप्ट लाइक दैट बिकॉज हमारी जो क्लासिकल फिजिक्स है, जो हमारी क्लासिकल अंडरस्टैंडिंग है, जो हम रोज देखते हैं, जैसे मेरे आसपास एक बॉटल है, कप है, एक फोन है, राइट, इन चीजों से ये एक्सप्लेन नहीं होता. इससे बहुत डिफरेंट है. something that is not similar to what we see around us. Okay, so superposition will not be intuitively understandable. मतलब देख के आपको एकदम से नहीं लगेगा कि हाँ यार ऐसा हो सकता है, because it is something very weird, something that weird that even Albert Einstein called it spooky. Right, he said कि यार ये क्या हो रहा है, ये तो मुझे ही समझ नहीं आ रहा. Right, because it's something very very weird. But चलो ठीक है, हम समझते हैं. This is called Schrodinger's cat. Erwin Schrödinger was a particle physicist. उसने एक experiment design किया to explain quantum superposition to people like you and me. तो उसने क्या कहा कि there is a box, ठीक है, एक closed box है, उसके अंदर there is this cat, let's call her C. So the cat C is in this box. Now in this box there is a glass of poison, a vial of poison like this, and यहाँ पे there is this lever जो जैसे ही इस वायल के ऊपर गिरेगा ये पूरी वायल एकदम से टूट जाएगी and the cat will die. Right, as soon as this thing falls, this poison will break and the cat will die. Right, now the thing is कि ये कब गिरेगा नीचे ये हमें नहीं पता. Right, otherwise cat will stay alive. Box में छेद है, ऑक्सीजन आ रही है, cat has been well fed, no problem. It can only die if the poison is released. Now when the poison will release we don't know. हमें it is random, कभी भी हो सकता है. Right, and the box अभी तो आपको you can see this as like you can see through it, but the box is closed. Box को बंद कर दिया हमने. Now you can't see inside the box. You can just see this. Okay, you can just see this. आपको बस ऐसा closed box दिख रहा है. अंदर you don't know that the poison has been released yet or not. हो सकता है release हो गया हो poison, हो सकता है poison ना release हुआ हो. Right, and you don't know if the cat is dead or alive. Right, so you close the box is now closed. If the poison gets released the cat will die. So now you tell me, without opening the box, is the cat dead or alive? You have to tell me, without opening the box, is the cat dead or is the cat alive? Till we don't open the box we cannot tell. You're absolutely right, हमें नहीं पता. But when we are just about to open the box, when we are just about to open, at that time the cat is both dead and alive. For us it could be dead or alive, it is both at the same time. It is only when we open the box and we look inside that we can say that the cat is either definitely dead or definitely alive. Till the box is not been completely opened, before we've just opened it, it is both dead or alive. So what is the cat doing? The cat right now is in a state of both death and alive at the same time. This is what is superposition. Something that can exist as two things at once. Now what is happening in the case of a quantum computer, we'll see. In the case of Schrödinger's cat, the cat is both dead and alive at the same time because we don't know, right? Only when we look we can know, right? For us, छोड़ो actual box में क्या हो रहा है, but for me it is both dead and alive. This is just a thought to explain what superposition is, right? If you go and search superposition, I can guarantee if you even spend 10 hours on it, you will not understand it completely, because it's not possible to understand it completely, because हमारी जो normal understanding है उससे वो समझ नहीं आता, right? So just a thought to understand what is happening, that from my perspective my cat is now dead and alive at the same time, but when I open the box I'll be able to see, right? So when I open the box I'll be able to see. Now this thought experiment is used to understand the quantum state of an electron. So superposition means that every quantum bit, or a quantum bit is the basic thing in a quantum computer. In a normal computer, it was a bit which was 0 or 1, 0 or 1, right? In a quantum computer or a qubit, it is 0 and 1. So it is both 0 and 1 at the same time. This is what quantum computing, the first principle is superposition. Both 0 and 1. Two states at the same time. Two positions superimposed on each other. Okay, two positions superimposed on each other. This is what a quantum computing first principle says, superposition. The quantum bit is both 0 and 1 at the same time. Is this much clear? Only then I'll move forward. Nimbats मुझे भी नहीं आता. I just know the thought experiment. Okay, if it's not clear, just understand it means that you are at two states at the same time. For me, the cat is both dead and alive at the same time. I don't know exactly, right? So I can think that it is both. Now this is what electron is doing at the quantum level. It is both a particle and a wave at the same time. Okay, so it is two states, state of 0 and state of 1 at the same time. Things that the normal computer sees only as OR. For example, अगर मैं आपको एक और example दूं, so if there is a coin in your hand, right, the normal computer can see it only as heads or tails. ठीक है, या तो वो heads देखेगा या tails देखेगा. But what a quantum computer sees, when I toss the coin, when it's up in the air, when it's revolving, that is what a quantum computer sees. It is both heads and tails. Till it lands, you will not know whether it is heads or tails. So a quantum computer will see a coin in the air that is revolving like this. So it's both heads and tails. But a normal computer will only see either heads or tails, right? So this is the first principle. Okay. Now I'm moving on to the second principle of entanglement. Okay. Now, so what happens in quantum entanglement? In entanglement, subatomic particles become entangled. Entangled means linked in such a way that change in one leads to the change in other, even if there is no connection between them. क्या कह रहा हूं मैं कि this is the first particle, this is the second one. When they come together, or when in quantum entanglement, they get linked. Now this link is in such a way that even if I send them to the opposite ends of the universe, if I change this, there will be change in this. कैसे होता है ये? I'll show you another thought experiment to explain this. ठीक है? Let's say you go to a McDonald's drive-thru. ठीक है? आप McDonald's में गए through a drive-thru. There you got a McChicken and a McVeggie. आपको दो चीजें खरीदनी थी. आपने एक खरीदा McChicken और एक खरीदा McVeggie. Now the McDonald's guy, rather than a normal process of giving you a red box for the non-veg thing and a green box for the veg thing, what did they do? They gave you a single box of brown color जिसमें दोनों है. So you now have two brown boxes. The McVeggie is also in the brown box and the McChicken is also in the brown box, right? So you looking at the box, you cannot tell अगर इसमें McVeggie है या McChicken है, right? But if I but you know कि यार this is one, this is two, एक में McChicken है, एक में McVeggie है. अगर मैंने ये खोल लिया, if I open the first box and I see that there is a McChicken inside, then I can see the second box. Without opening the second box, I will know that this is a McVeggie, right? Without opening the second box, I will know that this is a McVeggie, right? But before I open any of the boxes, मुझे नहीं पता कौन सा burger किधर है, right? Okay. Now you have two boxes. एक में McChicken है, एक में McVeggie है, right? If you open one, you'll know the other, but without opening, you don't know anything, right? Okay. entangled का क्या मतलब है? Change in one state will mean change in the other state. Change in one state will mean the change in the other state. अब मैंने क्या किया? मैंने let's stay here. Okay. What did I do? I had this one box and I had the second box. Both, I don't know which is what. मैंने इस बॉक्स को उठा के भेज दिया नॉर्थ कोरिया, and this box is still with me, right? This box is still with me and that one is sent to North Korea. Now, abhi bhi, regardless of where it is, it's in North Korea or in the Andromeda galaxy even. If I open this box and this comes out to be a mech veggie, I will know that the other one is a mech chicken, right? I will get to know its state because its state is entangled with the first one. अगर मुझे फर्स्ट वाले का पता है तो मुझे सेकंड का स्टेट भी पता चल जाएगा, regardless of how far it is. So they are sort of super linked. They are connected despite the distance between them, right? तो अब मैंने क्या किया? I took the two boxes. Both boxes were brown. I sent one to the Andromeda galaxy, and the second one I just opened here. And this came out to be a mech veggie. So the one in the Andromeda galaxy is a mech chicken. So I got to know about this one despite the huge distance between these two without touching it. So I could change or I could understand something about this from something here. This is entanglement, right? Change in one or understanding one or looking at one tells me about the other despite the distance between them, even if they are at the opposite ends of the universe. This is the second principle of quantum computing, right? This is the second principle, and this is called entanglement. Now, in case of entanglement, we are talking about electrons at a subatomic level. Okay, we are not talking about mech veggie and mech chicken. We are talking about electrons. Now, electrons have a spin. Okay, again, they're not actually spinning, but the spin is there to show their orientation. So let's say I say an electron has a positive spin like this, and I say the other electron has a negative spin like this. Okay, now there could be superposition of spin. The first principle, that is that it would look like this, both up and down spin at the same time, right? And what would I say in terms of entanglement? In terms of entanglement, when I put this one electron here and one electron on the other side, and if their states are entangled, if I know this, I will know about this too. Iski we'll just see a video to understand, and then I'll take your doubts. Okay. Now, if a coin is being flipped on a table, right? A coin is being flipped on a table. It is like an electron in both positive and negative spin, both heads and tails. The coin is being flipped as a घूम रहा है वो table पे. As soon as I stop it, or I look at it, or I open the mech veggie box, what will happen? I will have to stop it. I will have to place my finger. It will either be heads or tails. Either be heads or tails, nothing else, right? But जब तक वो घूम रहा है, तब तक I don't know, right? This is exactly what happens with the electron. Electron has a superposition of positive and negative spin. As soon as I look at it, as soon as I interact with the outside world, ये जो positive negative ये है, this will stop and I will see only one spin. This is like the coin is spinning and I stopped it here. Okay. The second case would be that the coin is spinning and I let it spin, then it would be superposition into both positive and negative spin. This is superposition. I hope this much is clear. Entanglement is connection between the two, right? Let's just move forward and see a video on entanglement, and then you'll probably get a better idea. Just hold on. Yeah. See, these are two electrons and they come together and their state gets entangled. They get together and they sort of get connected to each other, right? Now they had a positive spin and a negative spin, or a up spin or a down spin, right? So these states get connected to each other the way the mech veggie burger was. Now this is what superposition is exactly, right? This state of superposition is that, this state of superposition is that at any time it can be both positive and negative. That was superposition that we've already understood. Now we're going to talk of entanglement. Two electrons, I'm saying one has a positive spin and the other has a negative spin, or one has an up spin or the other has a down spin, right? Now they get entangled, they get connected, right? This is superposition of up and down. Okay, now there are two electrons, one is up, one is down. I took one electron and sent it to the Andromeda galaxy, and the second electron I kept on Earth. Now, the second electron is on Earth, the first one is in the Andromeda galaxy, right? If I look at the first one on Earth and I find out that, okay, I look at it and see, okay, it has up spin. So the second one now I immediately know has down spin. Now this is the spooky thing here. I have found out about something in the Andromeda galaxy which is so far away that it takes light to travel 100 years from Andromeda galaxy from here, but I have found this instantly. Instantly I have found what is happening in the Andromeda galaxy rather than waiting for light to travel from Andromeda galaxy to here. So I have been able to communicate faster than the speed of light, because some communication has happened, right? This communication faster than the speed of light directly contradicts the idea of E equals mc squared. And that is why Albert Einstein was also spooked when he did this. Okay, so let's continue. Now, Albert Einstein did not understand this, because he said that light, like this cannot happen, this is communication faster than light. So he called it spooky action at a distance, that electrons are entangled, and regardless of their distance, regardless of how far they are, if I just look at one, I will be able to understand the other. This is the second principle, entanglement. Is this clear? I know thoda tough ho raha hoga, but if you just understand superposition means two at once and entanglement means linkage this far apart, it would be fine, because UPSC mein they're not going to ask you how they work, right? They're just going to ask you what they are. So I hope this much is clear. I'll just look at your comments, then move forward. Aradhya, even Einstein couldn't understand this, but how they are connected, I'll tell you. The mech veggie is there, right? I have just opened the mech chicken on Earth and still found out that there is the mech veggie on Andromeda. So mujhe to communication ho gayi na Andromeda se, and it is instant. I didn't have to wait 100 years to understand, right? Okay. Now, what is happening in entanglement? That despite a huge astronomical distance, disruption in one electron or looking at one electron spin will lead to understanding the other electron spin also, right? This is quantum entanglement, because the subatomic particles have become entangled in such a way that any change in one disturbs the other, even if both are at the opposite sides of the universe. So now let me tell you superposition and entanglement together, right? What is happening in superposition and entanglement together? These two electrons are linked. Right now they are both in superposition. Up, down, up, down, up, down, up, down, up, down, like this, right? This is also in superposition. This is also in superposition, right? But, so they are both dead and alive right now, both of them. Now I take one here and I send the other apart. They will continue to stay in that up, down, up, down, up, down motion. But as soon as I interact with the outside world, as soon as one interacts with the outside world, as soon as I look at this through a microscope, interact with it, if this starts to then display positive spin, this will start to display negative spin. The first condition of both having up and down together is superposition. The second condition of looking at one and knowing about the other would be called entanglement. And this is basically because electrons are both particles and waves, right? But this you don't need to know, absolutely don't need to know. You just need to understand the first condition. superposition, that up down both for both electrons at the same time, they're both up and down. When I separate them, they remain up and down, but they are linked. So as soon as I look at one, as I interact with one, this shows up, the other one will always show down, right? This is both superposition and entanglement together. So let's understand, take a recap. There were two principles, superposition, entanglement. This we've understood. Now, बस अगर आपको समझ आ गया है, superposition means two states at once and entanglement means linkage. This much is enough for any question that UPSC will ask you on quantum computing. But I had to give you a slight background ताकि बाद में आपको अब आगे पढ़ने में आसानी रहे, right? Now, if a normal computer could see only 0 and 1, if a normal computer could see only 0 and 1, and this computer can see 0 and 1 together, so the ability of this quantum computer to process data, is much faster than any other computer, because it can see 0 and 1 together. It does not have to wait for a coin to be this, then this, then this, then this. It can see a flipping coin, right? It can see and understand and interpret a flipping coin. That is what a quantum computer is. And if you use these quantum principles in computing, you'll be able to make a quantum computer. Now, where can you apply this? Where are the applications of quantum computing? Basically, they are everywhere, right? Everywhere you can use a computer, you can use a quantum computer which is much faster. Of course, you cannot use it for checking your email or messaging someone on Instagram, but you can use it for complex problems, right? You can use it for sensing, chemistry, cryptography, mechanics, imaging, communication. The complex problems that computers do, all of them can be solved by quantum computer because it is ridiculously fast. And I'll just show you how fast it is. Okay, let's just go back to the basics for a minute. Qubits are the basics of quantum computing. So both values 1 and 0 simultaneously, right? Superposition, multiple states at one time, so a lot of speed. And entanglement, that two members of a pair, they get entangled, right? They get entangled, and change in one would lead to change in the other. Okay, now what is quantum supremacy? Quantum supremacy means that a quantum computer can solve the problems of mathematics, or let's say problems of computational issues or any equations, very, very tough complex maths that no classical computer can do, right? No classical computer can do, but quantum computer can do, because quantum computer is able to see both 0 and 1 at the same time. So it's very, very fast, right? So just to give you an idea of quantum supremacy, Google's quantum computer is called Sycamore. It was given a mathematical computational problem that it took 200 seconds to solve, right? The world's fastest supercomputer, I'll tell you what a supercomputer is just in a minute. The world's fastest supercomputer would have taken 10,000 years to solve this problem. Okay, so this is the difference of speed between a quantum computer and a supercomputer. And supercomputer is anyway much, much faster than any other laptop that we have. Okay, or laptop or computer that we have, right? So this is the difference, because it can see both 0 and 1 at the same time. Now, what are the advantages of quantum computing? There is speed, right? Of course. And there is storage as well, because 0 and 1 can both be stored in one electron. It can be used to do simulation, right? Simulation of, let's say I want to simulate how COVID models would happen, or how COVID would change the world, right? But before I go to the advantages, let me just read your comments. I hope you're just getting a basic idea. अगर आपको basic समझ आ गया है, what is superposition and what is entanglement, that is enough. And why a quantum computer is faster. Yes, Akash, it is related to Heisenberg's uncertainty principle, but I'm not going there. Karthik, how and why they're able to do this, even I don't know, and even scientists don't know yet. Okay, so again, just the basics. I'll just explain this thing again. अगर किसी को इसमें doubt था तो the electron has up and down spin. It is possible to have. In a superposition electron, it will have both up and down at the same time. Okay, it has both up and down at the same time. It's like this, right? Now two electrons, this is what? This is superposition, that it's both up and down at the same time. Now the computer is able to interpret this up and down. How it's able to do that, it's not important. Or, I mean, if you see, I'll never tell you to not read anything. I'm going to tell you, you go and Google superposition, waste 1 day, all right, on YouTube, and still if you understand, you come and tell me. Okay, because I have done this thing myself. Because they still don't understand it. There are many experiments here. There is the Young's double slit experiment. There is the Heisenberg uncertainty principle to understand whether it's a wave or a particle, right? Then there is a experiment of boxes where you separate the wave and particle functions and the up and down spin function. But again, I'm telling you, it is going to take a lot of your time, and it's going to waste a lot of your time because it's not required. You're not here to become a particle physicist. You're just here to understand what superposition means. So superposition means both up and down at the same time. Entanglement means that if one electron is here and the other one is here, once they come close, their states get linked. Now their states are linked. If I send this one here and this one here, when I interact with the outside world, when I look at this, if it shows a positive spin, the other one has to show a negative spin. The other one has to show a negative spin, even though it is in superposition right now. The McVeggie and the cat, of course, they are based on probability, but they are just thought experiments to explain this idea, right? Why is it called quantum computing? Let's go back to the first slide. Because our understanding of classical physics, the way things are, right? We understand things only as heads or tails, as dead or alive, as 1 or 0. But our understanding of classical physics is not enough to understand quantum physics. And that is why we need thought experiments or analogies to connect with them, right? That is why in the first slide it said that classical physics does not explain quantum physics. It is completely different. Okay, if they are entangled here, I send one here and I send one here, I look at this one, I interact this one out with the outside world, this will show up, then the other one has to show down. If this shows down, the other one has to show up, because their quantum states get entangled. The superposition thing is that they are both positive and negative, or both up and down at the same time. This is the cat and these are the burgers, right? Now अगर आपने burger के example में ही समझना है, before opening the box, the burger is both McVeggie and McChicken at the same time, right? This is what? This is superposition. Okay, now if I put this, now these two burgers are together, both McVeggie and McChicken at the same time. This is superposition. I put this one in the Andromeda galaxy and this one stays here. Now if I open this, I interact this with the outside world and I find that this is chicken, then the other one has to be veg. So this is entanglement. At the first stage it was both at the same time. In the second stage, when I open it, because of the entanglement, I get to know the state of both just by looking at one, right? Because they are connected. So these are the two things, superposition and entanglement. If the basic is understood, I'm not going to go more into that because I'll show you the questions that have been asked. Yeah, the questions I'll tell you. Do you know what question they asked? What is qubit? Qubit is connected to which technology? This is the question they're asking. So अब सोचो कि is it really worth understanding more about the particle and wave function of an electron and how it collapses and what the Heisenberg uncertainty principle is? It's not, right? बस एक basic idea हो जाए कि superposition and entanglement है, तो ये they ask this qubit is connected to which technology, right? So क्या point है? Why do we have to go beyond so much? We just understand this and let's move on, right? Now we've understood quantum supremacy and how fast the computer is, right? Now we'll understand its advantages. Of course, speed is an advantage, storage is an advantage, simulation, it can do data simulation. Let's say I want to forecast how COVID will grow, right? Then privacy. Privacy is a very important application here, right? How quantum computing can be done for cryptography. This I'll show you. Okay. Then secure communication, again, quantum cryptography. China has demonstrated this. ISRO has demonstrated this. It's in the news. It's called quantum key distribution. And this I'll tell you in detail. Okay. Then of course it has applications in research. देखो जब इसमें applications आए, if you get applications on questions like quantum computing, again think wide. There is no place where it actually can't be applied. Does it have applications in health? Yes. In agriculture? Yes. In education? Yes. In archaeology? Yes. In sociology? Yes. Because in sociology it could be used to predict models of how social groups will interact with each other, right? So it could be used everywhere. Research, agriculture, there is no difference, and you can just read these slides. Don't remember them. ऐसी चीजें बिल्कुल याद नहीं करनी है, right? Just don't remember them. In pharma, yes, because we'll be able to develop vaccines faster, something like that. Okay, this is it. Just read the applications. Now, augmenting industrial revolution 4.0. Yes, it will make the new industrial revolution that has Internet of Things, machine learning, AI, robotics better. It will help in AI and big data. AI we'll study tomorrow, right? So, हाँ बिल्कुल it will help AI and big data में, right? It's not going to be a problem. Weather forecasting में it's going to help. Disaster management में it's going to help. I'm just going to I've written this so that you know how to think. But इसके beyond you don't need to read, right? If you skip these slides also it's fine because it has applications everywhere, right? This is quantum supremacy, and Google's quantum computer Sycamore took 200 seconds to perform a calculation. At that time, Summit was the fastest computer. Now Fugaku is the fastest computer. It would have taken 10,000 years for Summit to do, right? Sycamore did it in 200 seconds. Okay. Now, what are the challenges? Challenges are, the first challenge is that we are facing right now. It is very difficult to understand, right? Second is decoherence. Now, what does this mean? The linked state, the superposition state. Quantum bits can lose that state sometimes. So that is decoherence, that they're not linked anymore. They're not superposition. They're not in superposition anymore. They lose that state. That would be decoherence. Then designing an algorithm will be tough. Cyber security will become a problem because, and why, I'll tell you in today's class only. And it has limited working. You cannot use a quantum computer for email. Okay. All right. Now let's understand quantum key distribution. Right? Okay. So first I have to tell you what cryptography is, or what encoded messages or end-to-end encryption that you read about, what it basically is. It is basically that, let's say I here on my WhatsApp, I'm sending a message to my father on WhatsApp, right? Right. And this message is then encoded into some data. Let's say this, it's encoded into X equal to Y, Z, C. This is not the actual message. It's encoded into this. It goes to my father's phone, and from X is equal to Y, Z, C, it gets converted back to the message, the original message, which was good afternoon. Okay. So this is encryption. Encryption is that through a mathematical equation, through a maths equation, I code one message, good afternoon, into X is equal to Y, Z, C. And then back into this. This is encryption, right? Now, if I have coded good afternoon into this, or my WhatsApp has coded this, if somebody else intercepts and sees my data, they will not see good afternoon, they will see only this, right? Now it is up to them if they have enough mathematical power to go from x is equal to yzc to good afternoon, because कोई system होगा, random encoding तो होगा ही नहीं. There would be some system like G is encoded like this or A is encoded like this. So if someone has a very fast computer, they can probably go from this to this, right? This is normal cryptography. It is a mathematical problem or a mathematical way to code from one place to other, right? I'll just again explain what I'm saying. Let's say the original message is good afternoon, and the encrypted message is x is equal to yzc. So there is a maths equation or some mathematical formula that is there for this purpose, right? This goes to my father's phone, and then his phone also knows the exact maths thing that is there, and he gets to see good afternoon. But if you interpret or you try to get into my data in the middle, you will only see x is equal to yzc. This is what end-to-end encryption is. This is what traditional cryptography is. Throughout life, cryptography has worked like this for basics in classical computing. Okay, that you use a maths problem to code, and then you send, and then it decodes it, right? This is what a maths problem is generally. Now, is this much clear? I'll just wait for a second. This is what traditional cryptography is. Vineet, you're saying teach a bit faster. Somebody will teach it's not. Somebody will say it's not clear. Please repeat. See, I cannot go. How am I supposed to cater to everything? I can go much faster than this, but okay, good. All right. So now this is what traditional cryptography is. From one side to the other, the reverse of this, going from here to here, from this to this. If you don't know the exact key, it's very difficult, right? So the first function is here, but this, for a foreign person to do this, is very difficult, right? This is what traditional cryptography is, that the adversary is unable to solve a certain math problem. But let's say you have too fast a computer that has a lot of ability to check for various equations. You could possibly go for solving cryptography, right? Now, what did they do? They started using quantum laws to do cryptography, so that even the fastest computer couldn't do it, right? And yes, the fastest supercomputer might be Frontier. This data is not important here. Focus on the principle that I'm teaching you. The quantum key distribution is what? It is using quantum keys or a principle of quantum computing to do this encryption, so that even the fastest computer can't solve it. How? See, pehle, why is it in the news? Because Meteus satellite by China has demonstrated quantum key distribution, and also a Bangalore based startup, QNU Labs, they have also shown quantum key distribution, and they work under this Innovation for Defense Excellence, which is the operational framework of the Defense Innovation Organization, right? It is like under the Ministry of Defense, we have the Defense Innovation Organization, and from the Defense Innovation Organization there is the IDEX, Innovation for Defense Excellence. So they, under them, there was this startup that was working, and they have demonstrated quantum key distribution, right? They have used quantum principles to do cryptography rather than mathematical principles to do cryptography. How? Let's see. What they will do is, let's say I want to encode a message from this place to this place. What I would normally do is I would send a message like this, send a message like this, and there would be a particular mathematical thing that only you know and only I know. So what I've coded for, you can see, but nobody else would be able to solve that math problem. This would be traditional cryptography. What they do is that from the satellite first, before doing any maths or anything, from the satellite, they generate two entangled photons. two entangled photons are generated, right? Or you can consider them entangled electrons. That is not significant. They are two entangled photons that are generated. Now, right now, what would the state of them be? They would be both up and down at the same time, both up and down at the same time. The boxes are both closed, right? They first generate two entangled photons and send them from place 1. You generate two entangled photons and you send them. One you send here, one you send here. This you've done, right? Now both places have an entangled photon. Now you start communicating. If there is an outside interference, that's what we're trying to stop in cryptography. If there is an outside interference, the entangled state of the electrons or the photons would come into play, and you will be able to see. It is like somebody from outside coming and opening one box. So it would be visible to you that a change has been made, that somebody has interfered from outside. Till they are in this system, they would not display their boxes, or the boxes are not opened. But as soon as somebody comes from outside, the boxes get opened. And as soon as somebody comes from outside, you will know that one electron will start showing up, the other one will start showing down, because somebody from outside has entered. So now this is cryptography happening without the idea of maths, only through the idea of quantum entanglement, right? So what you're doing is, your sender is instructing the satellite to generate two entangled photons, and they are then both beamed to ground station. Then they will compare the quantum states and see, you can constantly compare and see that whether they have been interfered with or not, if the box has been opened or not. If the box has been opened, right, and if one electron starts showing a positive spin and the other one starts showing a negative spin, it means that in this system there has been some external interference. This is what quantum key distribution is. So you are basically encrypting messages. After that, you can even send messages normally. If somebody comes from outside to see, you will find out instantly. And that is the goal of cryptography, that if somebody tries to interfere, you know what it is, right? So is system mein, if you start communicating and if somebody from outside comes, you will know instantly and the messages would be encrypted. This is what quantum key distribution is. It has two protocols. One is prepare and measure. Second one is called entanglement based. You just need to know the names of this, right? Both can be used to detect eavesdropping, right? It is entanglement based, and what you're doing is cryptography. Okay. Now this is considered future proof. Why future proof? Why was traditional cryptography not future proof? Because it just depends on your ability to solve a maths problem. So you have a fast enough computer, you can do it. But here, there is no way you can, regardless of how fast the computer is, if you interfere from the outside, the box will be opened and you will get to know whether the electron is positive or negative, right? This is why quantum key distribution is considered future proof. It is future proof means even in the future we can continue to use this technology and cryptography will never be a problem. We will always have secure communication. This is what quantum key distribution is, right? Now what are the challenges? Sometimes the transmission does not happen properly, sometimes there is communication loss, and there might be infrastructure shortfalls because not everywhere these satellites etc would be present. Okay, now after this we just have to see quantum computing in India and supercomputer and etc before we move on to blockchain. So I'll just read your comments and see if there are any problems. Eavesdropping means listening into listening into somebody what somebody else is saying. Bhavya, you can what I meant is it helps in communication and not in email. You cannot use a quantum computer to read an email, it's not built for that, is what I meant. Quantum computing can help you encrypt your email, right? Yes, this is what I was laughing at, Kaushal, not laughing at you, Bhavya. That he's saying that people want me to be in quantum state, teach fast as well as slow at the same time. Amitos, going fast and slow at the same time would not be entanglement, it would be superposition. Entanglement would be that. Okay, let's stop there, no worries. so many of you have said superimpose fast and slow at the same time, so that's fine. I hope you're understanding. देखो, quantum key distribution is, I sent two entangled photons this way, right? Now this is one system. Inside the system, they will always be in superposition, or they will be both up and down at the same time, or the box will be closed. But as soon as I interact from outside, right? As soon as I interact from the outside, this up and down at the same time would stop, and they would either show up or show down. This is what quantum key distribution is doing. I am here and my father is here. There is a system here. This system is made. What this system does is that now if somebody else tries to interfere, to stop the data, to stop the light that's coming, or to stop the communication signal, the electron that is entangled will stop showing its quantum state. It will stop being like this. It is entangled. The box will get opened and it will either become positive or negative. Inside this system, the box is always closed. And dekho yaar, you really do not need to go in this much depth. Even this much is too much for what UPSC needs, right? I will show you the previous year questions. Tomorrow we'll probably do a 25 question test. Okay, you will do all the questions on quantum computing and all the ones on emerging and critical technologies, and you'll understand कि भाई नहीं पूछते वो इतना detail में. If you just understand superposition means this together, up and down together, and entanglement means connection. Mech veggie say I cannot make it more simple than this. Just believe that example and understand from there. Okay, all right. Now let's understand quantum computing, what India is doing. So I'm just listing these things down. This is for mains. You can ignore this for prelims. Very unlikely that it's asked, or just read what I'm highlighting. There is a national mission on quantum technologies and application. There is a quantum information and computing lab in Bangalore. There is a quantum enabled science and technology research program, right? Again, sirf means ke liye, quantum frontier mission, DRDO young scientist lab for quantum technologies. Forget it, but this is fine. If you have to read this also, the thing you have to read is that they are running the quantum frontier mission. That's the only thing. Quantum frontier, so तुम्हें समझ आ ही रहा होगा किस चीज के लिए, right? Okay. Now let's see what a supercomputers are. Supercomputer is basically a large system that is made to solve complex problems, but what is it doing, right? It works on the same principle as traditional computer of 0 and 1. The only thing yet, it has more than one CPU. So it has many CPUs. So it is like a very fast traditional computer. Okay. The principle is the same, 0 and 1. It just has many CPUs or many things like that, right? So that is a supercomputer. And just trying to differentiate a quantum and a supercomputer. In quantum computer, the principles are different. In supercomputer, it's just you take too many of the CPUs in one place. Let's say you take 10,000 MacBooks, take all of their CPUs and you put them in one chip. That would make a supercomputer, and it would be still maybe 1 million times slower than a quantum computer, right? Okay. So supercomputing is measured in this floating point operations per second, or flops. Right, so these are basically measure of computers processing speed, how fast the processor is. And here of course there is more than one processor, so many processors, many processors have been put together, right? Petaflops is what the unit generally is, and petaflops is measured in 1,000 trillion flops. Flops means floating point operations per second, not the movies that Yash Raj makes. Okay, now floating point operations per second is a method to encode real numbers within limits of finite precision. Absolutely don't remember this. बिल्कुल नहीं समझ आ रहा तो कोई जरूरत नहीं है. Nobody is going to ask you. It just is a processing speed check. ठीक है, that's all you need to know. Fastest supercomputer earlier was Fugaku. Now I think it's Frontier. I'll update it tomorrow or whatever the information is. That's not important. Only the idea is important. What the principle here is parallelism, that many processors can work together in parallel, but they are still traditional processors. कुछ नया नहीं है. It is still only the old traditional processor. वही parallel में काम करके it's just working faster, right? So nothing new. It's just too many of what we already had. Okay. Now these are how you measure flops: mega, giga, tera, peta. These are like words, and you know these words already: megabyte, gigabyte, etc. Right? Okay. If a desktop computer, right, normal desktop computer is there, it has just one microprocessor, right? So it does not have that ability to work, but like its flops would be maximum to 1000 2000 flops, but otherwise you can go to 1 peta flops. So that is the difference. Now we have a national supercomputing mission in India. Who runs it? The mighty Ministry of Electronics and Information Technology, the Department of Science and Technology, CDAC, and the Indian Institute of Science, Bangalore. Okay, this is the only important thing here. What they're trying to do is they're trying to make a national knowledge network. They're trying to connect 70 places by giving them these supercomputers, and then connect universities, etc. together, so that they can do research. Okay, till now 11 have been deployed, and they're all with the name of Param. So Param Shivai, Param Shakti, Param Brahma. This Param prefix is meant to denote a supercomputer in India. So what they'll do, they'll put supercomputers in many research institutes, then connect all of them, right? So it will make a sort of a grid, a national supercomputing grid, so that research, etc. can be done much easier, right? What are the four main pillars here? There is infrastructure, applications, R&D, human resource. Again, not important for prelims. You can just skip through this. इसमें कोई इतनी बड़ी बात नहीं है. Param Ganga was launched recently. So these things, and of course, this is just a fast computer, so you can use it in everything, right? Okay. What are some other India supercomputers? There is Pratyush, there is Mihir. This is at the Indian Institute of Meteorology. This is at the National Center of Medium Range Weather Forecasting. Then there is Param Siddhi, right? And this will be India's fastest supercomputer at 210 petaflops. Then there is Param Shakti, Param Brahma. Again, details are not that important. Just you know that Param is for supercomputer and what a supercomputer does. Okay, now I have to explain blockchain to you. So today obviously is a difficult task, but if you understand blockchain and if you understand quantum computing, no real other emerging technology is that difficult to understand. So what we'll do is we'll take a break for 5 minutes. I hope you're enjoying today's class. I'm certainly enjoying, with the analogies of superposition and entanglement. I know it might not be absolutely clear to you, but you don't have to be a particle physicist. Let's take a break for 5 minutes. I'll read whatever comments you have, and then we'll come back and continue. I hope it's clear so far, and I hope you're enjoying. And if that's true, do tell me in the discussion. We'll come back in 5 minutes. Okay, welcome back. No offense to Yashraj. Sorry about that joke. If you like their films, I don't. But okay. So, good. It's great that you're enjoying, and we'll continue now, and we'll understand blockchain. Okay. Now, आपने पढ़ा होगा blockchain में already. You must have read this that it is a decentralized ledger, right? Now, the problem is that when we use words like this and we don't know what they mean, then we're unable to solve the questions that come from it. Okay, blockchain is, I'll start from the very basic. It is a chain of blocks that has a certain information. Let's see what that means, right? Okay, पहले आप सोचो कि why can't I make money into a digital file, like a file, like a Word document? Don't get confused with UPI, right? UPI is not digital money. UPI is just money या पैसा है जो है आपके अकाउंट में, it's just digitally transfer हो रहा है. पैसा आपके अकाउंट में है, digitally transfer हो रहा है, right? This is what UPI is. Okay, it's not digital money. E-rupee sort of is digital money but not really. But यहाँ पर क्या है, मैं कह रहा हूँ कि हम मनी को एक ऐसी फाइल बना देते हैं जो मेरे कंप्यूटर में स्टोर हो जाए, राइट? तो क्या होगा? 3 प्रॉब्लम होगी, राइट? पहले तो क्या है कि इंटरनेट सेंट्रलाइज्ड है, ठीक है? इंटरनेट सेंट्रलाइज्ड है. मान लो मैं उसको गूगल ड्राइव पे स्टोर करना चाहूँ उस फाइल को, तो वो फाइल कहाँ जाएगी? वो जाएगी गूगल के पास, एंड गूगल हैज द एबिलिटी टू देन see my files, you know, do anything they want with it, etc. तो मैं पूरी तरह गूगल को ट्रस्ट करता हूँ अपनी फोटोज के साथ, अपनी यूट्यूब की वीडियोस के साथ. गूगल हैज ऑल दैट इन्फॉर्मेशन. कल अगर गूगल मान लो मेरे से नाराज हो जाए, या जैसे उन्होंने अगर ये यशराज वाली बात सुन ली हो एंड दे हैव अ पार्टनरशिप, तो दिक्कत हो जाएगी. दे माइट डिसाइड टू डिलीट माई यूट्यूब चैनल, टेक एवरीथिंग अवे फ्रॉम मी, एक्सेट्रा, राइट? सो पहली चीज है दैट द इंटरनेट इज सेंट्रलाइज्ड. देयर इज अ सेंट्रल अथॉरिटी जो इंटरनेट को कंट्रोल करती है. नॉट एग्जैक्टली कंट्रोल, बट देयर आर दीज बिग कॉर्पोरेशंस, राइट? तो अगर मेरे को पैसा इसमें डालना हो और ऐसी फाइल बनानी हो तो इन अथॉरिटीज को ट्रस्ट करना पड़ेगा. दिस इज द फर्स्ट प्रॉब्लम. सेकंड, देयर इज नो स्कैरसिटी ऑन द इंटरनेट, राइट? अगर कोई एक इमेज है इंटरनेट पे तो उसकी कोई स्कैरसिटी नहीं है. यू कैन नॉट से दिस इज द ओनली वन. कोई भी उसको कॉपी कर सकता है, कोई भी पेस्ट कर सकता है, कहीं भी उसे यहाँ वहां डाल सकता है. तो स्कैरसिटी नहीं है, right? But in money there is scarcity. You cannot just copy one note, press Ctrl C on a 1,000 rupee note and make 2,000 rupee notes, right? You can't do that. So internet में second problem है कि scarcity नहीं है. Third thing is you might be able to hack, right? If it is done on digital platforms, you might be able to hack it. So these are the 3 problems of the internet. One, it is centralized. Okay, forget the money example now. Second, there is no scarcity on the internet, and third, it is possible to be hacked. So these are the 3 problems why we couldn't put money as a digital file on the internet, right? Now, blockchain solves exactly this problem. This problem of money cannot be digitized. This exact problem is solved by blockchain. Now, let me give you an example. These are the name of my 3 friends, Akshay, Pranjal, and Ashima, right? Let's say that they are doing certain transactions. That Akshay gives rupees 100 to Ashima, Ashima gives rupees 50 to Pranjal, and Pranjal gives rupees 30 to Akshay. Okay, अब ये transaction हो रही है. Normally, how would this happen? They would need to record that all these transactions are happening, right? If they are happening, let's say digitally, or they are happening over the phone, they would need to record them, right? For recording them, what you need is a ledger. Now let's say कि record करते करते the person who was maintaining this ledger is a person called Gunjan. Okay, now Gunjan is the central authority here, right? Gunjan is constantly checking कि अच्छा अक्षय ने 100 rupees दिए आशिमा को. Let's see how much money Akshay has left. Let's say he started with 150. He has given 100 here, so he has 50 left. Now he has reserved 30, so he has 80 now. So Gunjan is maintaining this ledger, and Gunjan is the central authority. Now, of course, Gunjan is not going to do it for free, right? So Gunjan will start getting rich only because she is maintaining this ledger as a central authority. तो इससे इन तीनों को बहुत प्रॉब्लम है, because ये बेसिक सा काम है, and this is what banks are doing for you. When I send you a UPI, the bank will check my account, it will check your account, then from my account it will remove certain money, in your account it will put certain money, correct? And the bank becomes a central authority, and of course you need to trust the bank कि वो आपके पैसे के साथ कुछ खराब नहीं करेंगे, राइट? तो हमने सोचा यार इसे डिसेंट्रलाइज करते हैं, लेट्स रिमूव द सेंट्रल अथॉरिटी। कैसे करते हैं? हम अपना लेजर खुद बना लेते हैं, लेट्स मेक अ लेजर आवरसेल्व्स। लेजर ही तो रख रहे थे, दे वर जस्ट कीपिंग अ रिकॉर्ड, राइट? तो मान लो ये ट्रांजैक्शंस हैं, आशिमा pays अक्षय ₹100, अक्षय pays प्रांजल ₹30 एंड प्रांजल pays आशिमा ₹10, राइट? आप ऐसे ट्रांजैक्शंस, बहुत सारी ट्रांजैक्शंस होती रहती हैं, एंड एट द एंड ऑफ द मंथ यू गेट टुगेदर एंड यू जस्ट टैली देम एंड यू से कि अच्छा यार इस मंथ में ये ट्रांजैक्शंस हुई एंड सबके पास इतने इतने पैसे होने हैं। बन गया लेजर। नाउ यू डोंट नीड अ सेंट्रल अथॉरिटी, राइट? एंड इफ यू स्टार्ट विद अ सर्टेन अमाउंट, मान लो आप यू स्टार्ट विद 10,000 रुपीज ईच एंड योर ट्रांजैक्शंस आर ओनली 150, तो जब तक आपको लगे कि यार अपना 10,000 का लिमिट कोई ब्रीच नहीं कर रहा है, आप तब तक टैली करने की जरूरत नहीं है। सो यू कैन इवन डिले द टैलिंग लेटर। सो बेसिकली अब क्या हो रहा है कि जितनी भी ट्रांजैक्शंस हैं हम लोग खुद रख रहे हैं, वी आर गोइंग टू नोट देम आवरसेल्व्स, नॉट गोइंग टू नोट देम इन सम अदर प्लेस। ओके, सो देखो अब ये ट्रांजैक्शंस होती हैं, पहली ट्रांजैक्शन होती है, यहाँ पे हमने बैलेंस लिखा, अक्षय हैज 100, आशिमा हैज 100, प्रांजल हैज 100। यहाँ गया, आशिमा pays अक्षय ₹100, अक्षय pays प्रांजल ₹10 तो ₹30 एंड प्रांजल pays आशिमा ₹10। ये पेमेंट हुई। अब आशिमा की ट्रांजैक्शन देखो, शी स्टार्टेड विद ₹100, देन शी पेड ₹100 हियर, राइट? So now she has how much? 0. And Pranjal then gave Ashima ₹10 here, so now she has 10. But in the next set of transactions, Ashima says, I have paid Pranjal ₹50. But clearly her bank balance was not okay, right? So if her bank balance was not okay, she could not have made this transaction. So Ashima is a liar. Sorry, Ashima. Okay, so she is a liar. She cannot make this transaction. But how do you find that out? To find that out, you need the record of all the previous transactions. ठीक है, आपको सब कुछ चाहिए पुराना to find out about this, right? So what will you do? You will maintain the transactions that happen in one set on a block, and then you will connect these blocks, right? You will connect these blocks in a chain to form a blockchain. So now there is transaction here, then there is transactions here, then there is transactions here. When you put this transaction here, you look at the previous transactions and see कि अरे यार इनके पास इतना enough balance था, did they have enough balance to make this transaction, so that future transactions are also validated. To validate future transactions, you need the record of the previous transactions, and that you do by putting all the transactions in a block and linking them together. Okay, all right. So now what we do is we say Akshay has ₹10, Pranjal has ₹10, Akshay pays Pranjal ₹1, right? तो मैं क्या लिखूंगा? Let's say this is my first block. So what will I write here? I will write A pays P ₹1, balance remaining P ₹11, A ₹9. Now अब of course I don't want कि ये डेटा सबके लिए अवेलेबल हो, एंड आई ऑल्सो वॉन्ट कि ये डेटा थोड़ा सा कोडेड हो। तो इसके लिए मैंने क्या किया, एक ब्लॉक का फिंगरप्रिंट बनाने के लिए, एक ब्लॉक को आइडेंटिफाई करने के लिए कि हाँ ये फर्स्ट ब्लॉक है, दिस इज द वन देयर वेयर वी हैव स्टार्टेड, ताकि डिसऑर्डरिंग भी ना हो, आई मेड अ क्रिप्टोग्राफिक नंबर बेस्ड ऑन सर्टेन मैथ्स। ये मैथ में आपको समझा चुका हूँ ये कैसे होता है। तो मैंने एक मैथ्स प्रॉब्लम के बेसिस पे क्रिप्टोग्राफिक नंबर बना दिया, जिसे कहते हैं हैश नंबर और वर्क नंबर और रेफरेंस नंबर। सो व्हाट आई डिड इज आई टुक दिस ब्लॉक एंड आई टुक दिस ब्लॉक। इसमें क्या लिखना है मैं बताऊंगा। सो इफ दिस इज अ ब्लॉक, दिस इज वन ब्लॉक दैट आई एम मेकिंग इन अ ब्लॉकचेन, इट हैज 4 कंपार्टमेंट्स। अभी हम सिर्फ फर्स्ट वाले का काम समझे हैं। फर्स्ट वाले में हम ट्रांजैक्शन की डिटेल्स लिख रहे हैं, वी आर जस्ट राइटिंग हियर कि क्या ट्रांजैक्शन हो रही है, right? This I am writing in the first component. There is still component 2, component 3, component 4 of a block that we are going to see right now. Okay. Second component में मैंने क्या किया? In the second component, I took a mathematical problem to make a cryptographic number or a hash number or a reference number, and I put that here. Okay. So in the second component, there is a hash number or a reference number. Got it? Now, अब बचे component 3 और component 4. हैश नंबर जो है ये कहां से इसकी इंफॉर्मेशन आई है? दिस इज इंफॉर्मेशन ऑफ कंपोनेंट 1, इंफॉर्मेशन ऑफ कंपोनेंट 3 एंड कंपोनेंट 4। मैंने इन तीनों इंफॉर्मेशन को लेता हूं और मैं एक हैश नंबर बनाता हूं। 3 और 4 में क्या है, आई विल जस्ट टेल यू, राइट? सो लेट्स से यहां पर इंफॉर्मेशन थी अक्षय पेज प्रांजल ₹1, प्रांजल ₹11 बैलेंस, अक्षय ₹9 बैलेंस, राइट? इसका मान लो ये ऐसा नंबर आया, दिस इज सम वर्क नंबर दैट वाज कैलकुलेटेड बाय द कंप्यूटर। नाउ क्रिप्टोग्राफी मीन्स कि यहां से आप यहां नहीं पहुंच सकते, राइट? इट्स वेरी डिफिकल्ट फॉर यू टू डू, यू विल हैव टू क्रैक दिस मैथमेटिकल प्रॉब्लम टू अंडरस्टैंड दिस, बट यहां से आप यहां जरूर पहुंच सकते हो, राइट? बिकॉज दिस इज हाउ द क्रिप्टोग्राफी इज हैपनिंग. Okay, now if I make any change in this, let's say I say Akshay pays Pranjal ₹2, then this work number would change completely, right? Because this is a cryptography of this particular data. If I just make a small change here, this would completely change. इससे ensure होगा कि कोई malicious वो नहीं होगा, right? Is this much clear? Then I'll move forward. Right, that I have a block, it has 4 components. पहले पे मैंने transaction लिखी, दूसरे पे मैंने एक हैश नंबर लिखा या रेफरेंस नंबर लिखा. रेफरेंस नंबर इज द फिंगरप्रिंट ऑफ दैट ब्लॉक, जिसमें कंपोनेंट 3 और कंपोनेंट 4 की भी इंफॉर्मेशन है. कंपोनेंट 3 एंड कंपोनेंट 4 आई विल टेल यू. नाउ हाउ इज द वर्क नंबर मेकिंग, हाउ आर वी मेकिंग दिस वन वे फंक्शन, दैट दिस इज द कंपोनेंट 1 की इंफॉर्मेशन, कंपोनेंट 3 की इंफॉर्मेशन, कंपोनेंट 4 की इंफॉर्मेशन. आई पुट देम टुगेदर एंड आई गेट दिस नंबर. इस नंबर से यू कांट गो बैक टू दिस इंफॉर्मेशन अगेन बिकॉज इट्स कोडेड. सेकेंड थिंग इज, अगर आपने यहां पे कुछ चेंज किया तो ये पूरी तरह से चेंज हो जाएगा, ठीक है? इज दिस मच क्लियर टू यू? आशिमा चिट फंड मारेगी वो मुझे अगर उसने देख लिया आई एम यूजिंग हर नेम हियर. यार आफ्ताब देखो, यू आर आस्किंग मी इफ आरबीआई कार्ड टोकनाइजेशन इज कनेक्टेड विद इट. क्या मतलब यार, वाई? जस्ट फोकस ऑन व्हाट आई एम, जो मैं बता रहा हूं वो तो पढ़ लो पहले. ओके गुड, ऑलराइट. अब क्या है, मान लो देयर इज अ न्यू ट्रांजैक्शन, ठीक है? अभी तो एक सेट ऑफ लेजर, यार कोई पूछ रहा था व्हाट इज अ लेजर. लेजर इज जस्ट अ प्लेस वेयर यू राइट ट्रांजैक्शंस. लेजर इंग्लिश वर्ड है, आप डिक्शनरी में भी देख सकते हो. इट्स जस्ट अ प्लेस वेयर यू राइट ट्रांजैक्शंस. नॉर्मल ट्रांजैक्शंस लिखने की भी एक जगह लेजर कहते हैं उसको, ठीक है? ओके, नाउ लेट्स से दिस इज द फर्स्ट ब्लॉक. एक ऐसा ब्लॉक है जिसमें कुछ डेटा अबाउट what the bank details are is written, then there is a work number, then there is component 3 and component 4 which I don't know. Now let's say I have to add a new block, right? ये पहला set of transactions था जिसमें अक्षय had ₹1 और ₹10 and Pranjal has ₹10, right? Let's say यहाँ पे now there is, I have to add a new block, but इस block को validate करने के लिए, ये देखने के लिए कि इसकी transactions ठीक हैं, मुझे इस block की information चाहिए होगी, राइट? तभी तो मैं यहाँ बता पाऊंगा. अगर यहाँ पे लिखा है अक्षय हैज ₹10 और इस ब्लॉक में मान लो लिखा है कि अक्षय पेज ₹100, तो ये तो ऐड नहीं हो सकता. तो टू वैलिडेट और टू ऐड दिस आई वुड नीड टू गो फ्रॉम द प्रीवियस वन. ओके, मुझे प्रीवियस वन की इंफॉर्मेशन चाहिए होगी. तो कैसे करूंगा मैं पुराने ब्लॉक को नए से कनेक्ट? जो थर्ड कंपोनेंट है उसमें मैं पिछले ब्लॉक का रेफरेंस नंबर लिख दूंगा. ओके, सो पहले कंपोनेंट मैंने लिखी इसमें डिटेल्स ऑफ ट्रांजैक्शन, यहां मैंने लिखा है इसका हैश नंबर और क्रिप्टोग्राफिक नंबर. ये मैंने नेक्स्ट ब्लॉक के थर्ड कंपोनेंट में लिख दिया. तो अब जो सेकंड ब्लॉक है इसका जो हैश नंबर है इसके किस बेसिस पे कैलकुलेट हो रहा है? एक तो जो नई ट्रांजैक्शन हुई है वो, और एक पिछले उसका हैश नंबर, तो ये उससे कनेक्ट हो गया. इफ आई चेंज दिस डेटा नाउ, लेट्स से आई चेंज दिस डेटा, इफ आई चेंज दिस डेटा दिस विल चेंज, देन दिस विल चेंज, देन दिस विल चेंज, राइट? आई होप दिस इज क्लियर. इफ आई चेंज दिस डेटा हियर, मान लो मैंने अक्षय ने कहा कि यार ये लेजर जो है ना मैं इसको चेंज करता हूँ, यहाँ पे मैं कहता हूँ बस 10,000 रुपए हैं, एक्चुअली 100 नहीं है. तो क्या होगा, ये हैश नंबर यहाँ पे चेंज हो जाएगा बिकॉज वो तो इस ओरिजिनल डेटा के बेसिस पे था. इट हैड सेड यू हैव ₹Y लेफ्ट या ₹10 लेफ्ट. अक्षय हैड ₹10 लेफ्ट, ही चेंज्ड इट इनटू ₹10,000. तो क्या होगा, दिस हैश नंबर विल चेंज. नाउ इफ दिस हैश नंबर विल चेंज, इट इज एग्जैक्टली कॉपीड इनटू द नेक्स्ट ब्लॉक. ये हैश नंबर इनसे डिराइव हुआ था, ये यहाँ कॉपी हो गया. नाउ दिस हैज चेंज्ड. अब ये अगर चेंज हो गया तो इस सेकंड ब्लॉक का हैश नंबर भी इस पे डिराइव हुआ था, तो ये भी चेंज हो जाएगा. पर ऐसे करके पूरी आपकी वही चेंज हो जाएगी, राइट? द पूरी चेन ऑफ ब्लॉक्स विल गेट चेंज इफ यू चेंज जस्ट वन एंटिटी, right? So you can't change old entities, the entire old entries, the entire blockchain would get affected. तो अभी हमने क्या समझ लिया कि ब्लॉकचेन में हर ब्लॉक में 4 कंपोनेंट होते हैं. फर्स्ट में ट्रांजैक्शन, सेकंड में उस ब्लॉक का रेफरेंस नंबर, थर्ड में पिछले ब्लॉक का रेफरेंस नंबर, एंड फोर्थ में क्या होता है वो हम अभी देखेंगे. अब ये जो रेफरेंस नंबर है ये इसके बेसिस पे है और इसके बेसिस पे है. ओके, ऑलराइट. दिस ब्लॉकचेन वेयर डज इट एग्जिस्ट? ये ट्रांजैक्शन, ये लेजर जो है जहां ये बातें लिखी हैं, ये कहां एग्जिस्ट करती है? दिस एग्जिस्ट ऑन योर कंप्यूटर, नॉट ऑन द सर्वर्स ऑफ अ सेंट्रलाइज्ड टेक जायंट लाइक गूगल. ठीक है, गूगल पे नहीं एग्जिस्ट कर रहा है, नॉट कीपिंग इट ऑन गूगल ड्राइव. ये आपके कंप्यूटर पे भी है, मेरे कंप्यूटर पे भी है. एवरीबडी, लाइक दिस देयर वर 3 पीपल हियर, आशिमा, प्रांजल एंड अक्षय. तो इन तीनों के कंप्यूटर्स पे ये पूरी चेन है, राइट? Now, what is a blockchain? It is a record of transactions, means it is a ledger. It is not on a central system. It is maintained with everybody's computer, so it is decentralized. तो अभी हमने बस इतना समझा that it is a decentralized ledger. Okay, let's move forward. हमने और क्या देखा कि there is a hash number, right? Hash number is a unique fingerprint of one block generated on the basis of component 1 and component 3. Now, if there is a new transaction, right, and new transaction होती है, तो there is validation, means you add a new block to the already existing chain of blocks after looking at the previous ones. If you make any illegitimate content, let's say you change your balance from rupees 10 to rupees 10,000 in one of the blocks, here it will be a change, then here it will change, then here it will change, here it will change, here it will change, so the entire thing will change, right? Okay, so blockchain is not centralized. There cannot be illegitimate content. Everyone has a copy and anyone can validate, right? Anyone can validate means when a new transaction comes, anyone can look at the previous set and see कि अच्छा यार इतना बैलेंस है भी सही इनके पास, अगर है मैं तभी नए ब्लॉक को अपनी चेन में डालूंगा, नहीं तो ये चेन यहीं पे खत्म है, I am not adding this new block. Okay, when a new transaction happens, when a new block comes, let's say a new block comes, here it's written first block, second block में यहाँ पे लिखा है अक्षय has rupees 10, प्रांजल has rupees 15. New block says प्रांजल pays rupees 5 to अक्षय. Now this is possible, so you will just look at the previous ones, you will see हाँ यार ये transaction possible है, तो आप इसको भी अपने block में add कर लोगे. Okay, I hope यहाँ तक everything is fine, no issues still here. I'll just show you what happens. Let's say ये 3 लोग हैं, आशिमा, प्रांजल एंड अक्षय. इन तीनों के पास अपनी अपनी ब्लॉकचेन है, ठीक है, जिसमें ये सारी ट्रांजैक्शन की इंफॉर्मेशन है. एज यूजुअल आशिमा को पैसे चाहिए लाइफ में बहुत ज्यादा, तो उसने क्या किया, उसने यहाँ पे अपने पैसे बहुत ज्यादा बढ़ा लिए, राइट? उसने कहा कि नहीं यार 10 नहीं 10,000 रुपए हैं. तो इस ब्लॉक का रेफरेंस नंबर चेंज हो गया. जब इस ब्लॉक का रेफरेंस नंबर चेंज हुआ तो यहाँ ब्लॉक नंबर 7 चेंज हो गया, फिर ये चेंज हो गया, फिर ये चेंज हो गया, फिर ये चेंज हो गया. ऐसे करके थिंग्स केप्ट चेंजिंग. एंड रिमेंबर दैट न्यू ब्लॉक्स आर ऑल्सो बीइंग एडेड, राइट? और ट्रांजैक्शंस होती जा रही है. पीछे जाके अगर वो कुछ चेंज करना चाहेगी तो उसे ये सब कुछ चेंज करना पड़ेगा, राइट? एंड अब ये जो 2 लोग हैं ये देख लेंगे कि अरे यार ये तो कुछ गड़बड़ लग रही है, ये तो सेम है ही नहीं, तो दे विल जस्ट डिस्कार्ड दिस चेन एंड प्रांजल एंड अक्षय विल से कि दीज आर द ओरिजिनल चेन्स. यही जो है यही एक्चुअल इंफॉर्मेशन है. जो आशिमा कह रही है वो बिल्कुल गलत है, उसका लॉजिक गलत है, शी जस्ट वांट्स मनी, राइट? सो दिस इज अ ब्लॉकचेन, सो इट इज हैक प्रूफ एंड चेंज रेजिस्टेंट एज वेल एज डिसेंट्रलाइज्ड, right? Because it exists on everybody's computer, everybody has the records and the blocks are connected to each other. So if you make any change, the change will be everlasting. You will find out in every place that the change has happened. And ये लोग कहेंगे कि यार ओरिजिनल तो ऐसा ही था, इसको डिस्कार्ड करो, इसकी जरूरत नहीं है, right? Is this much clear to you? Okay, अब देखते हैं. Now, since all are linked, you can't randomly change any record, right? It is change resistant, hack proof, right? Now, what is happening? Let's say there are 3 people, or let's say there are 5 people here in this set who all have their own, who all have their blockchains. 5 blockchains सबके पास हैं. अब नया ट्रांजैक्शन आता है तो वो नया ट्रांजैक्शन सबको दिखता है कि ये नया ट्रांजैक्शन आया है. दे कैन ऑल सी एंड एड इट टू देयर चेन, राइट? दे कैन ऑल सी एंड एड इट टू देयर चेन. तो ऐसे करके नई ट्रांजैक्शंस भी वैलिडेट हो जाती हैं, समथिंग लाइक दिस, ठीक है? यू हैव न्यू ट्रांजैक्शंस, दे कैन गेट वैलिडेटेड, यू ऑल हैव योर चेन्स, इट्स डिसेंट्रलाइज्ड, इट्स ऑन योर कंप्यूटर, look at the previous transaction and say कि हाँ this transaction is possible, I'll validate it. Okay. Now, what is missing here is accountability. What if all of these 5 people want to start changing things at once? वो एक ही बार में 5 लोग चेंज कर दें, ठीक है, सबको अपने पैसे बढ़ाने हैं, तो now you will not even know which the original chain is, right? आपको पता ही नहीं चलेगा. And what happens here when all 5 people changes, that you will just end up with 5 different chains. So you will not even know which one was the right one, right? So if 10,000 people want to change a blockchain simultaneously in 10,000 different computers, right? So 10,000 different chains will be there, right? तो अब हमने अब क्या प्रॉब्लम है? There is lack of accountability. How can you make it accountable कि लोग ऐसे ही मजे में चेंज ना कर दें, right? तो आपने क्या किया? What you did was that to change anything on a blockchain, to change anything or to add a new block, right? To change anything or to add a new block, you need to do a lot of work. मेहनत करनी पड़ेगी आपको बहुत ज्यादा, कुछ भी एक चीज यहाँ पे चेंज करने के लिए. तो आप ऐसे ही मजे में चेंज नहीं करोगे. You will have to do a lot of मेहनत, ताकि एक ट्रस्ट और एक वैलिडिटी एस्टैब्लिश रहे. Now this work needs to be done to change any blockchain. So changing anything becomes tough. कैसा वर्क होता है और क्या करते हैं वो हम देखते हैं. जस्ट अंडरस्टैंड कि ताकि सब लोग रैंडमली उठा के चेंज ना करने लगे, हमने एक वर्क का क्राइटेरिया डाल दिया. यू विल हैव टू डू सम वर्क, ओनली देन यू विल चेंज द ब्लॉकचेन. ओके, अब जो फोर्थ कंपोनेंट था उसमें हमने क्या किया? हमने डाला समथिंग कॉल्ड अ वर्क नंबर. ठीक है, आई टेल यू व्हाट दैट मींस नाउ. पहले ब्लॉकचेन में फर्स्ट कंपोनेंट में क्या है? ट्रांजैक्शन डिटेल्स. सेकंड में क्या है? इस ब्लॉक का रेफरेंस, जो कहां से आया है? फ्रॉम component 1, from component 3 and from component 4. I'll just write here 1 2 3 4. In component 2, whatever information is there has come from whatever information is there in 2 3 and 4. 1 is the transaction details, this is fine. This is the previous block, this also we know. Now let's see what the work number is. हमने एक रूल बना दिया कि हर ब्लॉक का जो रेफरेंस नंबर है, every block's actual reference number, this इन कंपोनेंट 2 में ये मैंने रूल बना दिया कि ये जो रेफरेंस नंबर है यहां पे, दिस ऑलवेज मस्ट स्टार्ट विद 4 zeros. ये 4 zeros से ही स्टार्ट होना चाहिए, राइट? अब देखो, ये इंश्योर करने के लिए कोई तो वैल्यूज होंगी जो यहां पुट होंगी, जिससे ये 4 zeros से स्टार्ट हो जाएगा. इस वैल्यू को तो मैं चेंज कर नहीं सकता, इस वैल्यू को मैं चेंज कर नहीं सकता. द ओनली वैल्यू आई कैन चेंज इज दिस. तो हाउ डज इट वर्क इज, मैंने कह दिया कि रेफरेंस नंबर ऑफ एवरी ब्लॉक मस्ट स्टार्ट विद 0. To get 0 0 0 0 in the first 4 digits, I have to manually enter, not center, manually enter numbers from 1 to 1 million in the fourth component. ये जो वर्क नंबर वाली जगह है, यहां पर मैं मैनुअली बैठ के 0, फिर 1, फिर 2, फिर 3, फिर 4, फिर 5, फिर 6 ऐसे लिखूं टिल 1 मिलियन. ऐसी कोडिंग है कि एट सम रैंडम नंबर यहाँ पे जो रेफरेंस नंबर है वो इट विल स्टार्ट विद 0 0 0 0, बट मुझे नहीं पता वो कब आएगा. सो बहुत मेहनत है टू मेक अ न्यू ब्लॉक एंड टू चेंज एन ओल्ड ब्लॉक. दैट इज व्हाई इट्स कॉल्ड अ वर्क नंबर. मैंने ये कोड डाल दिया कि सेकंड कंपोनेंट, दिस कंपोनेंट मस्ट हैव अ रेफरेंस नंबर इन एवरी ब्लॉक दैट स्टार्ट्स विद 4 zeros. टू अचीव दैट यू एंटर manually numbers here from 0 to 1 million, and at some place you will achieve that criteria, right? Now for this you will require a lot of computational power. बहुत मेहनत करनी पड़ेगी, बहुत बारे नंबर एक एक करके कंप्यूटर को डालने पड़ेंगे, तब जाके ऐसा एक स्टेज आएगा when this place has this, right? So now for changing a block or to add a new block, a lot of effort needs to be done. So this is called a work number. अब आप मजे में चेंज नहीं करोगे unless you have some real incentive, right? आप मजे में चेंज नहीं करोगे because एक आपको सारे चेंज करने पड़ेंगे, right? I'll explain what I'm saying. Let's say now Ashima again wants some money, right? ऐसा एक ब्लॉकचेन बना हुआ है हमारा and आशिमा को लगा है नहीं मुझे तो पैसे चाहिए ही चाहिए, right? तो उसने क्या किया, उसने यहाँ पे अपना ट्रांजैक्शन चेंज किया, उसने यहाँ ट्रांजैक्शन अपना चेंज किया, तो यहाँ रेफरेंस नंबर चेंज हो गया. अब उसे यहाँ पे वर्क नंबर चेंज करना पड़ेगा ताकि ये रेफरेंस नंबर 0 0 से स्टार्ट हो, राइट? फिर उसे यहाँ का वर्क नंबर चेंज करना पड़ेगा, फिर उसे यहाँ का वर्क नंबर चेंज करना पड़ेगा. सो शी हैज टू डू अ लॉट ऑफ कॉम्प्यूटेशनल एफर्ट टू एंश्योर कि सारे रेफरेंस नंबर्स 0 0 से ही स्टार्ट हो. इस प्रोसेस में नए ब्लॉक्स भी ऐड हो रहे हैं, नई ट्रांजैक्शंस भी हो रही हैं, राइट? एंड चेंज हियर वुड चेंज एवरीथिंग टिल द लास्ट ब्लॉक. तो अगर किसी ने लास्ट ब्लॉक में भी उसकी चेन में देख लिया कि आशिमा's चेन इज नॉट राइट, सो दे विल नो कि हाँ यार it's not correct, right? She's doing something wrong. So you cannot change every transaction at your own pace, because there is a lot of work required, b nine transactions are happening and everybody can see it, right? So if someone sees that the reference number of the last block of Ashima's chain is not correct, it has no zeros in the beginning, then there would be a problem. So even if Ashima wants to change everything, she does not have enough time. So the old entries cannot be changed. If 10,000 people want to change, उसके लिए हमने क्या किया, हमने मेहनत ही इतनी करवा दी that you can't do, like आप कर ही नहीं सकते कि 10,000 लोग इतना ज्यादा एफर्ट कर रहे हो. And there is also a risk, अगर पता चल गया कि आपने चेंज किया है तो you will be out of the system, right? So this is the way to add accountability or add what is called the work number, right? अब ये बात है कि न्यू ब्लॉक्स आर कॉन्स्टेंटली बीइंग एडेड, नई ट्रांजैक्शंस तो हो रही हैं, राइट? तो इट बिकम्स वेरी डिफिकल्ट टू चेंज अ ब्लॉकचेन. आपको हर ब्लॉक में ट्रांजैक्शन चेंज करनी है, वर्क नंबर चेंज करना है, फिर नेक्स्ट ब्लॉक का वर्क नंबर चेंज करना है, फिर नेक्स्ट ब्लॉक का वर्क नंबर चेंज करना है. तो इट्स वेरी डिफिकल्ट टू चेंज इट. अ लॉट ऑफ मेहनत इज रिक्वायर्ड. एंड द लॉन्गेस्ट चेन, जो भी ब्लॉकचेन में लॉन्गेस्ट चेन है, वो सबसे ज्यादा सिक्योर है क्योंकि वो सबसे ज्यादा कनेक्टेड है, राइट? सो आई होप इतना क्लियर है, right? Even if the basics of this is clear, it's fine. That it's a decentralized ledger. I'll tell you what you need to have understood. A, it is a decentralized ledger. B, that old entries cannot be changed. C, new entries, old entries cannot be changed. New entries can be added easily. Okay. And all entries are visible to everyone. Right? If this is understood, then we'll move forward. Okay, I hope this much is clear. There is a student Ashima here. I'm so sorry. It's not what I meant. If my friend Ashima finds out, it will be a huge problem. Okay, good. If it's clear to you, good. अरे just hold on, अभी बताता हूँ. Okay, now अब देखो, अभी हमने क्या देखा, हमने ये देखा कि फॉर एवरी न्यू ट्रांजैक्शन लेट्स से आई एम पुटिंग अ न्यू ब्लॉक, उसके लिए भी मुझे वर्क नंबर कैलकुलेट करना होगा, फोर्थ कंपोनेंट. एंड वो है बहुत ही मुश्किल काम. ठीक है, बहुत मुश्किल काम है टू कैलकुलेट द वर्क नंबर और टू कैलकुलेट दिस फोर्थ कंपोनेंट फॉर एवरी ब्लॉक. अब नया ब्लॉक आएगा तो वो भी मुझे करना है, एंड दैट्स नॉट ईजी, राइट? आई हैव टू वर्क, बहुत कॉम्पिटिशनल एफर्ट है. तो कोई क्यों करेगा, राइट? न्यू ट्रांजैक्शंस नीड टू बी वैलिडेटेड. somebody in the system needs to say कि मैंने सारी पुरानी ट्रांजैक्शंस देख ली हैं, ये नई वाली ठीक है और मैं इसे ब्लॉकचेन में ऐड कर रहा हूँ, राइट? बट व्हाई वुड समवन डू इट? उसे क्या इंसेंटिव है इतनी मेहनत करे वो? एंड दिस इज नॉट फिजिकल मेहनत, दिस इज कॉम्प्यूटेशनल वर्क. यू विल रिक्वायर वेरी हाई लेवल कंप्यूटर्स, ग्राफिक चिप्स एक्सेट्रा एक्सेट्रा. तो ये कॉम्प्यूटेशनल एफर्ट तुम्हें करने की जरूरत है, तो कोई क्यों करेगा, right? This validation here, validation of a new transaction, to understand that this new transaction is fine with our previous chains, it also requires the calculation of work number. It also requires you to see the previous blocks, right? This process of validation of adding a new block to the existing block is what is called mining. जो कहते हैं ना ब्लॉक बिटकॉइन माइन कर दिए, this mining is this validation of new transactions happening. Okay, now why would you want to remain a good actor? Why would you want to do this? Why would you want to validate transactions? Why? Okay, every time you validate new currency, let's say you validate for our entire system, we have 10,000 people, but you are the one who calculates the work number of the new block, you will get certain money, and that money in digital language is called tokens, right? So if you are doing this validation, right, here there are blockchains, there are 10,000 people, right? There is already this chain existing. Now let's say this new transaction here has to be added, right? Somebody says कि यार ये transaction हुई है. Now what you do is you check all the previous blocks, then you calculate the work number required, right? And then you say yes, it's fine, and then you add it here, and then you send this new chain. Earlier it was still here, then you send this new chain to all other computers and then they store it. तो आपने बहुत मेहनत करी, तो आपको मिलेंगे certain tokens. Tokens is just fancy word for money in the digital space. Okay, you will get some tokens. Now these tokens is your reward for mining or for validating new transactions or for doing the work that you have done, the effort, the computational effort. बैठ के कोई मेहनत नहीं करनी. The computational effort you have done. What have you actually spent? You spent electricity. You have spent graphic power. Okay, you have spent cooling power. बिकॉज आपका बहुत बड़ा कंप्यूटर होगा, बहुत बड़ा सर्वर होगा, कूलिंग सिस्टम चाहिए होगा, इलेक्ट्रिसिटी चाहिए होगी, आपने वो स्पेंड किया है टू कैलकुलेट दिस वर्क नंबर. सो यू आर गिवन सम टोकन्स और मनी एज अ रिवॉर्ड. नो व्हाट इज द इंसेंटिव फॉर यू टू नॉट डू समथिंग बैड? एक तो बहुत ही कंप्यूटेशनल पावर चाहिए वैलिडेशन के लिए, तो आप कोई जान के खराब वैलिडेशन नहीं करोगे, राइट? एंड जो ये करेंसी आपको मिलती है, राइट, ये करेंसी आपको मिलती है, दीज आर कॉल्ड टोकन्स. इनकी वैल्यू तभी तक है जब तक आपकी चेन वैलिड है, उसमें कोई गलत वैलिडेशन नहीं है, उसमें सारे ट्रांजैक्शंस वैलिड है. जब तक आपकी चेन में सारे ट्रांजैक्शंस वैलिड है, तब तक आपकी इस टोकन या आपकी इस करेंसी की सर्टेन वैल्यू है. अगर आपकी चेन में यू आर द वैलिडेटर एंड यू मेक समथिंग रॉन्ग, तो आपके टोकन्स की वैल्यू खत्म. एंड सिर्फ आपके नहीं, सबके टोकन्स की वैल्यू खत्म. जितने लोग उस चेन में पार्टिसिपेंट है, सबके टोकन्स की वैल्यू खत्म. सो नोबडी विल वांट टू बी अ बैड एक्टर. नोबडी विल वांट टू ऐड धक्के से चेंज ट्रांजैक्शंस. बेसिकली नोबडी विल वांट टू बी आशिमा. ओके, ऑलराइट. नाउ वैलिडेशन नीड्स ट्रस्ट. ओके, वैलिडेशन नीड्स ट्रस्ट. आपको ट्रस्ट करना पड़ेगा कि यार मैंने इस चेन में इन्वेस्ट किया है, इस चेन में मैं अपनी ट्रांजैक्शंस रखता हूं. एक बंदा यहाँ पे इस चेन में नए ब्लॉक्स ऐड करता है, सो आई नीड टू ट्रस्ट कि ये नया बंदा जो ऐड कर रहा है ये ब्लॉक ठीक ही ऐड करेगा वो, राइट? एंड हियर ट्रस्ट डज नॉट मीन दैट आई विल ब्लाइंडली ट्रस्ट देम. देयर नीड्स टू बी सम मेथड. तो 3 मेथड्स हैं टू एंश्योर दैट व्हेन न्यू ब्लॉक्स आर एडेड दिस ट्रस्ट इज एस्टैब्लिश्ड. फर्स्ट इज प्रूफ ऑफ वर्क, second is proof of stake, and third is proof of authority. Let's see this. Proof of work. Proof of work मतलब है कि वर्क नंबर कैलकुलेट करने के लिए आप to validate a transaction, to add a new block, you have to calculate the work number. बहुत ज्यादा computational power और electricity चाहिए, and you get tokens for demonstrating that you have done this work, right? अब होता क्या है, मान लो एक blockchain system में there are these many blocks, right? These are already there. There are 4 blocks in this blockchain system and there are 5,000 people in it. Or let's say there are 4 crore blocks, right? कोई फर्क नहीं पड़ता. There are 5,000 people. Now I have done a new transaction that has certain information, but अभी ये इस blockchain में add नहीं हुई है. अब यहाँ पे बहुत सारे लोग हैं जो कहते हैं भाई हमारे पास computational power है, ठीक है, हमारे पास computational power है, हम तैयार हैं तुम्हारे ब्लॉक को ऐड करने के लिए. Here I will check and add your block, क्योंकि मुझे ये काम करने के लिए पैसे मिल रहे हैं, मुझे टोकन मिल रहा है. तो इन सब लोगों में क्या होगा, they will compete, they will all get to see this new block. ये सारा ट्रांजैक्शन जो आएगा ये सबको विजिबल होगा कि एक नया ब्लॉक आ गया. They will compete with each other and try to get the like to solve this computational problem and to calculate the required work number. Obviously competition है तो कोई एक ही जीतेगा. This person calculates the work number, राइट, एंड दिस पर्सन देन सेज कि हाँ मैंने कैलकुलेट कर लिया, मैंने सब देख लिया, ये यहाँ पे ऐड हो जाता है, राइट? तो इस बंदे को फिर क्या मिलेगा, टोकन एज रिवॉर्ड. और ये जो बेचारे बच गए बाकी, इनको क्या मिलेगा, कुछ भी नहीं, बिकॉज दे लॉस्ट इन द कॉम्पिटिशन. इन्होंने भी कॉम्पिटिशनल पावर यूज करी, एनर्जी यूज करी, बट सिंस दिस पर्सन हैड द मोस्ट कॉम्पिटिशनल पावर, ही वॉज द वन विद द fastest computer and the fastest ability, he was able to add this block and he got certain tokens, right? So ये क्या चक्कर हुआ, ये हुआ यहाँ पे इशू कि भाई इन लोगों ने सारी इलेक्ट्रिसिटी यूज करी, सो मच एनवायरमेंटल प्रॉब्लम मस्ट हैव हैपेंड बिकॉज ऑफ दिस कॉम्पिटिशन बिटवीन दीज माइनर्स और वैलिडेटर्स. देयर वाज ह्यूज spent of computational power. When computational power was spent, computers चलते रहे, servers चलते रहे, environmental problems हुई and water wastage हुई in cooling systems. So this is a problem in Bitcoin. Every time a new transaction has to be added, it has to be done through proof of work only. Okay, and this proof of work has a problem that it has environmental issues. So every time a new transaction is made, lot of carbon emissions are happening. राइट. सो दिस वाज द फर्स्ट वे जो हमने देखा है, वर्क नंबर कैलकुलेट करो, नया ब्लॉक ऐड करो, बट इसकी ये प्रॉब्लम थी. दिस इज व्हाट बिटकॉइन वाज फेसिंग. नाउ सेकंड प्रॉब्लम हियर इज 51% अटैक. नाउ 51% अटैक, जस्ट नीड टू नो, आपको बस इतना जानना है कि 51% अटैक इज कनेक्टेड टू प्रूफ ऑफ वर्क. इतना बहुत है, ठीक है. अगर अभी जो मैं आगे बोलूंगा वो नहीं भी समझ आता तो कोई बात नहीं, बट मान लो कि ये जो माइनर्स थे यहाँ पे जो हमने अभी देखे थे, जो नए ब्लॉक्स को ऐड करते हैं, इसमें एक बंदा ऐसा है जिसकी कॉम्प्यूटेशनल पावर इज 51% ऑफ द होल सिस्टम्स कॉम्प्यूटेशनल पावर. मतलब इसका कंप्यूटर इतना स्ट्रांग है कि वो बाकी सब से मिला के भी ज्यादा पावरफुल है. ओके, दैट लाइक लेट्स से देयर आर 6 people here, so he has 51% computational power by himself in the system, and this he has 2%, 3% ऐसा. So now his compute, even if they all come together, their computational power is not the same as this one person's computational power. So if he has 51% computational power, then he can change whatever he wants, or he can add or change whatever he wants in the new transaction, because now when the new transaction comes, he is so fast at it that his chain is always the longest. बाकी लोग compete ही नहीं कर सकते, and he can choose कि हाँ मैं 2 transaction accept करूंगा, एक नहीं करूंगा. So he will destroy the entire idea, or destroy the entire idea of the decentralized power, because ये हो गई centralized authority, and now they can change what they want because they have enough computational power to change this and to validate or not to validate whatever they wish to. मान लो 3 transactions आई, 3 blocks आए, he says I will take this, I will not take this, let's say 3 new blocks are there, and he says that I'll accept this block, this one I won't accept, right? But he's so fast कि अभी उसकी chain already आगे बढ़ गई है, तो पीछे आप इतनी मेहनत करोगे, you will still be behind him, right? नहीं समझ आ रहा है ये तो कोई बात नहीं, just remember the term 51% attacks, because he has more computational power than everybody else combined. He can solve the computational puzzle faster than all others, and this person will constantly have the longest chain. We have already understood that the longest chain is the most secure. Blocks keep coming very very soon. हर एक सेकंड में 10 से 12 ब्लॉक आते हैं. So since his computational power is so fast, उसकी चेन हमेशा longest रहेगी. तो आप कभी बता ही नहीं पाओगे कि has he done something wrong or not, because he has this much. So this is the idea of proof of work. ओके, इन बिटकॉइन. इसमें 2 प्रॉब्लम थी. पहली प्रॉब्लम एनवायरमेंट, सेकंड प्रॉब्लम कॉम्पिटिशनल पावर. इज दिस क्लियर? यार 51% कॉम्पिटिशनल पावर अचीव करना इज नॉट अ इजी टास्क. ओके, बहुत मुश्किल है ये. इट इज जस्ट अ हाइपोथेटिकल सिनेरियो, इट यूजुअली डज नॉट हैपन. सेकंड क्वेश्चन वाज हु गिव्स द टोकन्स. आपने कोड में लिख रखा है दैट आउट ऑफ नोवेयर दिस टोकन विल बी जनरेटेड. आउट ऑफ नोवेयर दिस टोकन विल बी जनरेटेड. इस चीज को भी मैं अभी आपको एक्सप्लेन करूंगा. आउट ऑफ नोवेयर, लाइक इट्स लाइक प्रिंटिंग न्यू मनी. टोकन जनरेशन इज लाइक प्रिंटिंग न्यू मनी. ओके, ओके. नाउ सेकेंड थिंग यू वांटेड टू डू इज, अब आपने कहा यार प्रूफ ऑफ वर्क में तो वैलिडेशन में बात बन नहीं रही है. क्यों नहीं बन रही है? बिकॉज एक तो यार बहुत ज्यादा एनवायरमेंटल एफर्ट है. 51% अटैक हम छोड़ देते हैं, बट एनवायरमेंटल एफर्ट बहुत ज्यादा है एंड वी आर पोल्यूटिंग. तो अब आपने क्या कहा? आपने कहा है वैलिडेशन ही करानी है ना, लेट्स डू इट थ्रू अ डिफरेंट वे. हमने कहा दैट एवरी पर्सन हु विशेस टू वैलिडेट अ न्यू ट्रांजैक्शन, राइट, दे नीड टू पुट सर्टेन टोकन्स दैट दे हैव ऑन स्टेक. जैसे मान लो यहां पे सेम थिंग है, वी ऑलरेडी हैव दीज मेनी ब्लॉक्स, ठीक है, वी ऑलरेडी हैव दीज मेनी ब्लॉक्स एंड अ न्यू वन इज टू बी एडेड. इफ अ न्यू वन इज टू बी एडेड हियर, ठीक है, तो हमने क्या कहा, ये सारे लोग हैं who want to say that yes I can add new blocks, right? So we want to say that okay, if you want to add this block, you put certain things on stake. Stake means collateral. आप collateral रखो इतनी चीज कि आप खराब नहीं करोगे कुछ, right? Whoever wants they can put their collateral and they can then validate the new transaction. तो इसमें क्या हुआ, कंपटीशन तो खत्म हो गया कंप्यूटेशनल पावर का. अगर एक बंदा है जिसके पास ज्यादा कॉइन्स है, जिसने ज्यादा पैसे रख दिए, जिसने ज्यादा कहा कि यार देखो मैं 10,000 टोकन रख रहा हूं, मैं कह रहा हूं मैं गलत काम नहीं करूंगा, तो आपके पास ट्रस्ट भी हो गया कि यार ये तो अपने खुद के टोकन रख के कह रहा है. टोकन की वैल्यू ही तब तक है जब तक वो गलत काम ना करे. तो ही हैज इंसेंटिव नॉट टू डू एनी बैड वर्क अगेंस्ट हिज ओन चेन. एंड देन ही सेज दैट आई पुट दिस स्टेक, कि मैं अपने 10,000 टोकन स्टेक पे रखता हूं, कोलैटरल रखता हूं. अगर मैंने कोई गलत काम किया, किसी ने ये प्रूव कर दिया दैट आई हैव डन सम रॉन्ग वर्क, दे कैन टेक द टोकन्स दैट आई हैव पुट एट स्टेक, राइट? तो अब देखो कंपटीशन तो खत्म हो गया. I put 10,000 tokens. If I have done something wrong, if you prove I have done something wrong, you can take the 10,000 tokens from me. So now, right? So now competition is over. It is much more environmentally friendly, right? Now, usually there is no competition because block creator is one who has the most tokens. ठीक है, अब क्या है कि most likely एक group of people होगा इस system में, 4-5 होंगे. इन 4-5 का क्या होगा, इन्हीं के पास सबसे ज्यादा tokens होंगे, right? These are the ones who have the most tokens. तो हमेशा इनको ही मिलता रहेगा, right? उसको एक बार उन्होंने वैलिडेट करना स्टार्ट किया, उनको टोकन्स और मिलते गए और मिलते गए और मिलते गए, तो फिर तो इट विल जस्ट अगेन स्टार्ट बिकमिंग सेंट्रलाइज्ड. तो इसका क्या तरीका निकाला, that since almost always the same person gets to validate, the same person who has these many tokens gets to validate, there is no reward for making a block. So the block creator only gets a transaction fee. You will not get more tokens for transactions now. You will get only a transaction fee, right? क्योंकि हमने computational power तो अब लगा नहीं रहे, अब मेहनत तो है ही नहीं. There is no computational power or that much effort now. It is only a stake that you are putting what you already have on board to show your trust, right? So it has replaced this proof of stake, POS, proof of stake, has replaced what were earlier miners. Miner क्या करता है, effort करता है. Miner just like uses their axe to do effort, right? Effort को, work को, miner को replace कर दिया आपने with validator, with someone who says take this 5,000 tokens that I have, and if you can prove that I've done wrong work, you can take them from me, right? If not, I'll get them back. तो आपने validation से replace कर दिया. तो अब आप उनको नए token नहीं देते. अगर आप उनको अब नए token देने लगो तो फिर तो they'll get super rich again without doing any effort. So what you do, you just give them a small transaction fee. ठीक है, so you replace the miners with validators and you reward only the top stakeholders. Only the top stakeholders. How do you reward them? Not with tokens but with transaction fees, and this results in less energy consumption. Okay, this is proof of stake, the second way of establishing trust of adding new blocks. The third way is proof of authority. Now proof of authority is on the basis of identity. You don't put stake, you don't put work. What you say is, you say my name is Dr. Shivan Chaudhary, I have been in this organization for this long, this is my identity, I work here, I have this reputation, and I am validating this block. So you give up your anonymity, or even if it is but you give up your identity. Your identity is the value that creates trust in this system, right? Your identity is the value that creates trust in proof of authority. प्रूफ ऑफ अथॉरिटी को डिटेल में समझने की जरूरत नहीं है, प्रूफ ऑफ स्टेक और प्रूफ ऑफ वर्क को भी डिटेल में समझने की जरूरत नहीं है, बट जस्ट गेट द आइडिया. ओके, नाउ दिस एडिंग ऑफ न्यू ब्लॉक्स दैट वी वर डूइंग, व्हिच वाज आवर फाइनल प्रॉब्लम नाउ इन ब्लॉकचेन, दिस एडिंग ऑफ न्यू ब्लॉक्स, देखो ये व्हाट इज इट बेसिकली डूइंग. आपने एक नया ब्लॉक ऐड किया एंड देन दिस चेन विल नाउ गो टू एवरीबॉडीज, दिस चेन विल नाउ गो टू एवरीबॉडीज कंप्यूटर, राइट? सो व्हेन समथिंग गोज टू एवरीबॉडी, व्हाट इज इट कॉल्ड? कंसेंसस, right? When everybody agrees, आपने नया ब्लॉक ऐड कर दिया and then everybody's computer will goes and everybody will say यार इसने validate किया, सही है. तो consensus, right? That's what it's called when everybody agrees. So it is a consensus protocol. This way of how you will get everybody to agree on a new block is called consensus protocol. Consensus protocol. How everybody will agree on the new block. It could be through proof of work, that everybody will say, validator will show that they have worked. It could be proof of stake. Validators will show that they have put some stake, or proof of authority. that validators have a decent identity, right? These are the three ways to add new blocks. Okay, now what is the recent development? There is a cryptocurrency called Ethereum, right? They switched to this software called Merge. What it did was it started using proof of stake mechanism rather than proof of work mechanism. तो इससे क्या हुआ, energy requirement slash हो गई, right? What is Ethereum? Ethereum is a decentralized blockchain platform used to build decentralized apps and smart contracts and cryptocurrency. In words का meaning हम अभी समझते हैं, ठीक है? They have changed from proof of work to proof of stake. Now, अब इस टर्म को समझाता हूं मैं आपको. Blockchain is a system. It is an idea that I can link transactions. अब इन transactions में आप पैसे की बात करो, आप अपने डिजिटल सर्टिफिकेट्स डालो, आप अपने हेल्थ रिकॉर्ड्स डालो, आप लैंड रिकॉर्ड्स डालो कि ये लैंड पहले किसने खरीदा था, फिर किसने खरीदा, आप कुछ भी करो. Blockchain is what? Blockchain is a technology. Cryptocurrency is one application of blockchain. When you put money or the idea of money into blocks, then it is cryptocurrency, right? The tokens that you get, that tokens will amount also to the cryptocurrency. And why the word cryptocurrency? Because हमने देखा था there was hash number or reference number, that was the crypto thing, the cryptography. And currency means that you're putting the information of transactions into the block. Okay, justice for Ashima. So cryptocurrency is basically one application of blockchain. Okay, this is what Ashima was doing, this is what we were understanding. But you can put anything in the blockchain, not just the transaction records of money, but also the records of what land you have owned or what health you have or something like that, right? So that is what you would do. Now this is how a new block enters into the blockchain, and you can just read it here. I've already explained. This is differences between proof of work and proof of stake. Okay, ये भी मैं आपको कहूंगा आप एक बार पढ़ लेना from the slide, but I have already explained, right? I have already explained this exact thing, right? So I hope it's not a problem here. एक चीज यहाँ पे I'll just read it with you, right? First thing, how does it work? In proof of work, to add each block, miners must compete to solve a difficult puzzle. This is clear. In order to add a malicious block, you would have a computer powerful than 51% of the network. ये बात भी हमें clear हो गई. The first miner to solve the puzzle is given a reward, and proof of work consumes more energy. This is clear. Now let's come to proof of stake. There is no competition because it is chosen by an algorithm based on the user's stake. This we have known. Now to add a malicious block, यहाँ पे in proof of work, to do a malicious thing, to add a bad block, what did you need? You needed 51% computational power, right? Here what do you need? You will obviously need 51% of all the tokens or 51% of all the cryptocurrency on the network. If you have enough tokens than everybody else combined and you can still bid, then you can do a malicious thing. The problem here is that why would you do it? Because if it's invalidated, you will lose your own cryptocurrency also. And this situation almost never happens because there are so many people. 51% of all the cryptocurrency getting owned is almost impossible. And that is how, because this is an impossible figure, this is how the system remains decentralized. Okay, again यहाँ देखो, proof of stake, no reward for making a new block, no cryptocurrency, only a transaction fee. No tokens are given. Now POS replaces miners with validators and results in less energy consumption, right? अब अगर आप सिर्फ करंट अफेयर्स पढ़ो तो वहां सिर्फ इतना दिया है, right? This is why I had told you that you need background information to understand the words that are written here, right? It has taken 1 hour for us to understand this, but trust me, it is important because अब आप भूल नहीं सकते इसको, and you will not have a problem कि अरे यार ये क्या लिख दिया है, कहां से आ गया, right? Okay, now let's understand that blockchain is a decentralized ledger technology. It was first made for the development of cryptocurrency in 2009, which was Bitcoin, right? It has many systems, distributed systems आपको समझ आ गया, cryptography समझ आ गया, and series of blocks है, this we know, right? These slides you can skip over, इसमें कुछ खास नहीं लिखा है. The only thing you need to remember here is that एक तो cryptographic hash algorithms हैं जिसके थ्रू ये secured होता है, ये हमने समझ लिया कैसे. एंड दीज आर सम ऑफ द नेम्स ऑफ ब्लॉकचेन्स, ऑफ ब्लॉकचेन प्लेटफॉर्म्स, राइट. ओके, नाउ this is India's blockchain strategy or blockchain framework. What we are predicting is that by 2030, right, blockchain would be a foundational technology for 30% of all technologies, right? So what we are doing something like blockchain as a service. Blockchain as a service हमें तब समझ आएगा जब हम software as a service पढ़ लेंगे, which we are going to read tomorrow. Okay, now what are the objectives of a national strategy on blockchain? अब देखो यार, आपको उस दिन मैंने समझाया था कि अगर मान लो किसी भी टेक्नोलॉजी में कुछ भी करना है तो देयर इज अ फ्रेमवर्क, है ना. उस फ्रेमवर्क में ही आप चीजों को नोटिस करो, राइट. देयर वुड बी पीपल, देयर वुड बी फंड्स रिक्वायर्ड, देयर वुड बी इंफ्रास्ट्रक्चर रिक्वायर्ड. देन आफ्टर द प्रोडक्शन विल हैपन, you will require it to have IPR, you will require it to be regulated, then you will require it to be matched with the industry, right. And when the final thing happens, again here you will require IPR when the final thing is produced, and you will require to export it or to ensure that there is a level use of it. तो ये सारी बातें किसी भी ब्लॉकचेन स्ट्रैटेजी में होंगी. तो ऐसी चीजों को प्री के लिए नहीं पढ़ते और मेंस के लिए भी नहीं पढ़ते, बिकॉज इन चीजों से आप समझ सकते हो, राइट. जस्ट अंडरस्टैंड, इसमें कोई देयर इज नो रॉकेट साइंस हियर. हम एक्चुअल रॉकेट साइंस पढ़ चुके हैं, राइट. तो हमें ट्रस्टेड डिजिटल प्लेटफॉर्म बनाने हैं, हमें स्किल डेवलपमेंट बढ़ानी है, इनोवेशन बढ़ानी है, टेक्नोलॉजी डेवलपमेंट बनानी है, इंडिया को ग्लोबल लीडर बनाना है, स्टेट ऑफ द आर्ट ट्रांसपेरेंट टेक्नोलॉजी होनी चाहिए, सर्विस डिलीवरी टू सिटीजन शुड बी गुड. बोल बच्चे नहीं है, these things you don't read, right, because this is obviously going to be there. It's not a rocket science here, right. What is the components of the national strategy? Geographically distributed nodes. ये बताता हूं मैं आपको. नोड क्या है? Every actor in the system, जितने भी एक्टर थे, जितनों के पास वो चेन उनके कंप्यूटर पे थी, उसे हम नोड कहते हैं. माइनर नहीं, एक्टर. एक्टर मीन्स एवरीबडी. माइनर तो वो है जो वैलिडेट करता है नए ट्रांजैक्शन को. नोड है जो उस सिस्टम का पार्ट है, तो उसके कंप्यूटर में भी वो चेन एग्जिस्ट करती है. R&D करना है, बिल्कुल करना है. इंडिजिनस ब्लॉकचेन प्लेटफॉर्म बनाना है, अवेयरनेस करना है, डिजी लॉकर जैसी बाकी सर्विसेज से कनेक्ट करना है, राइट. दीज थिंग्स आर नॉर्मल. नाउ वन टर्म यू नीड टू रिमेंबर इज प्रेसिडियो प्रिंसिपल्स. Just remember that Presidio principles are connected with blockchain. They were given by the World Economic Forum. So they can sometime ask Presidio principles, connected with which of these technologies, etc. Now, first country that gave legal tender status to Bitcoin was El Salvador. And आज, after this class ends, please read cryptocurrency from economy. अब आपको अलग level समझ आएगा. ठीक है? Now, these are the potential applications of blockchains. Just read them. कोई इसमें बड़ी बात नहीं है, right? And like in currency, it has applications in banking, in inventory, in health, in property ownership, in smart contracts that update regularly because they are linked through blocks, right? IPR, you can store किसका intellectual property कहाँ है. You can make good governance in India chain. This is India putting apps like DigiLocker, Umang, etc. on blockchain. On corruption, you can do audits and you can see people's bank balances, etc. So blockchain की बहुत applications है, right? Cryptocurrency की बात करें तो क्या है? This is digital currency secured by cryptography. ये भी हमें समझ आ चुका है, right? It is decentralized. There is anonymity here. There is ease of transfer. Cross-border trade can be done because across the world Bitcoin is accepted. It is like worldwide cash, right? इसके advantages भी हैं, disadvantages भी हैं. So we're just going to see that. एडवांटेजेस क्या है? डिसेंट्रलाइज्ड है. जो लोग गवर्नमेंट्स, बैंक्स इनको ट्रस्ट नहीं करते, उन लोगों के लिए दिस विल लीड टू बेटर फाइनेंशियल इंक्लूजन. सेकंड क्या है कि एनोनिमिटी है. आपका डेटा कोई स्टील नहीं कर सकता, ठीक है, कि इफ यू आर ऑन द ब्लॉकचेन. एंड हाउ दैट्स डन आई विल जस्ट शो यू. ठीक है. देन देयर इज ईज ऑफ ट्रांसफर. इट्स डिजिटल, सो इट कैन बी डन इजीली एंड इट कैन बी डन थ्रू क्रॉस बॉर्डर ट्रेड कैन ऑल्सो बी डन हियर, राइट. ओके. Now, how does a cryptocurrency wallet or how does cryptocurrency transactions work? अब हम ये बात समझते हैं. So I'm just waiting for 2 minutes, just hoping that everything is clear and then we'll go. हमने blockchain का basic समझ लिया. अब हम समझ रहे हैं कि cryptocurrency में transaction कैसे होती हैं between 2 or 3 people, right? How cryptocurrency works? Transaction होने के बाद क्या होगा? This we have understood. Now, how the transactions happen? This we have to understand. So I'm just taking a break for 2 minutes, or rather let's take a break for 5 minutes. I'll just see your comments in that time and then we'll come back. We'll do blockchain and NFT today, or maybe Web 3.0 and blockchain and NFT today. This will, उसके बाद कोई खास conceptual काम नहीं है. Tomorrow I'll go to the studio and from there we'll continue the rest of emerging technologies and computers. इसके बाद on Saturday we're going to have a class on IPR and role of scientists and some of the health and space topics that we left. So Saturday will be done with science and tech. Only energy topic will be left, and energy I want you to study with environment. Okay, not here. So that I'll do there. All right, so just taking a break for 5 minutes and reading your comments. Hope everything is clear so far. हेलो, ओके। सो देखो, हमने ब्लॉकचेन का बैकग्राउंड समझ लिया। ओके, जस्ट 1 सेकेंड। हमने बैकग्राउंड समझ लिया है, बट दैट्स सॉर्ट ऑफ नॉट एवरीथिंग दैट वी नीड टू अंडरस्टैंड हियर। हमें बस समझ आना चाहिए कैसे काम करता है, ताकि जब हम इसकी एप्लीकेशन जब पढ़ें तो वी should have an idea. Somebody was saying that adding new transactions is easy, I said once, and once I said that proof of work is required. Adding new transactions is easy means that इस system में नए transactions add हो सकते हैं seamlessly for you. You don't have to do the proof of work. The background is such that the new transactions that will be added, that will be validated appropriately. For you, it's easy as a user, not easy if you are a miner, right? Like there's a difference. If you're a user, you just have to do the transaction and send it. अपने आप हो जाएगा वो पीछे में, आपके लिए easy है. What is happening in the background is not important for you. Okay. Now, timer is done. Okay. अब आगे समझते हैं. ठीक है. देखो, how does a cryptocurrency thing work at a user level? For me and you who are not mining, we just have to do transactions using cryptocurrency. ठीक है. Okay. Now, the wallet होता है, जैसे पेटीएम का वॉलेट है, राइट? वैसा सिमिलर वॉलेट यू हैव अ क्रिप्टो करेंसी वॉलेट. इट हैज टू थिंग्स. इट हैज अ पब्लिक की एंड अ प्राइवेट की. ओके, नाउ पब्लिक की इज public, means it is like your email address. So let's say I have to pay you, if I have to pay you certain bitcoins, I can pay you at this particular email, right? And the private key is like your password. Okay, private key is unique and it is known only to you. Now let's say there is an instant transaction, right? There will be an instant transaction. जैसे email send होता है वैसे ही है, मैं पैसे भी send कर सकता हूँ, right? This is what happens in a blockchain. I have to send I have to send Bitcoin to this particular email, which is the public key, and you have your private key. आप जब private key डालोगे तो आपको आपका Bitcoin और आपको अपना wallet दिख जाएगा. Okay. Now, what are the disadvantages of cryptocurrency? Advantages तो काफी हैं. It's instant transaction, easy to do, etc., etc. There is vulnerability because the hidden nature of transaction. इसमें आपने money transaction कर लिया, government कहीं involved नहीं हुआ. So terror funding, money laundering, and tax evasion, वहाँ पे this could become a problem. Secondly, RBI and Ministry of Finance have no control over this, right? So since they have no control over this, they can't tax it. That is why what they're doing is now they're taking capital gains tax from your account, but they have no idea what your transaction actually was, right? जो आप transaction कर रहे हो, this is anyway in economy, I hope you'll read it there, but whatever transaction you do, that they have no idea over. They can only see the bank balance that you have increased in your account. When you sell your cryptocurrency for real money, they can only tax that, but they can't tax cryptocurrency because they can't even see what you're doing because it's anonymous, right? So you can do terror funding, you can do money laundering, you can evade tax constantly because उन्हें पता ही नहीं है आप कौन हो. There is a private key you have and a public key, and it's happening there. Government has no control here because it's decentralized. There is no central authority that controls the money, right? Now, there can be frauds and scams. For example, this Squid cryptocurrency came out. It was a scam. In the name of cryptocurrency, everybody wanted to invest and it came out to be a scam. Second problem is that एक गो में payment हो जाती है. Now, since there is no central authority, no law, nothing regulating it, आप कभी कह ही नहीं सकते मेरे साथ फ्रॉड हुआ है. यू विल नेवर गेट द मनी बैक. नो रोल बैक मैकेनिज्म इज देयर. So these are some of the disadvantages. Again, I'd expect that cryptocurrency you will read for economy. I'm just giving you an idea. Okay. What are the other problems? Acceptance is a problem. Many countries will say it's not legal. Then it's a risky investment, right? Then hacking risk is there. Volatility risk is there, right? Hacking, how hacking can happen in a cryptocurrency? The block cannot be hacked, but your private key can be hacked. Your wallet can be hacked. Okay, that is what the hacking means. The transaction is hack proof, but your wallet is not hack proof. Okay, your private key somebody can find from like it's like finding your email password. Then there is volatility issue. Blockchain ki value is goes like this. Bitcoin ki value, sorry. It was like this and went down and now it's here. It's called crypto winter or something, right? वो ऊपर नीचे होता रहता है. Recently also some cryptocurrency collapsed, right? So it is volatile. So these are the issues of cryptocurrency. Again, only important for memes. If you want to see the disadvantages, like in short, firstly, how will you obtain cryptocurrency? A, you can mine for it, वो हमने देख लिया, validation कराओ, mining करो, तो e-waste, this is a problem. Second is you sell goods to the owner of a cryptocurrency and you get cryptocurrency. In this case, what will happen? It is untraceable, there's money laundering, there could be terror finance, there is no central authority. These are the disadvantages. And there is something called sovereign function of money creation. This is a political concept. It means that money creation is a power that only a state should enjoy, or a reputed political entity like a state should enjoy. And यहाँ क्या हो रहा है? You have created money without the authority of a state. So through blockchains and through cryptocurrency, you have undermined the authority and legitimacy of the state, leading to anarchy. Right? इतना डिटेल में समझने की जरूरत नहीं है. But this is just an idea that since money creation instills legitimacy, हमें लगता है अगर स्टेट ने मनी बनाया है, स्टेट ने पैसा बनाया, तो हम उसकी रिस्पेक्ट करते हैं. बट इफ नाउ देयर इज एन ऑल्टरनेट मनी, एक डिफरेंट टाइप का पैसा है मार्केट में जो स्टेट ने नहीं बनाया, देन इट बिकम्स अ प्रॉब्लम. थर्ड थिंग इज यू एक्सचेंज लीगल टेंडर फॉर क्रिप्टो करेंसी. यू give them rupees and you will get cryptocurrency. Again, you will tax organizations and terror finance and illegal trade. You can't stop it because cryptocurrency is anonymous. There is just a public key and a private key. अब public key आपको लगता है email की तरह, बट मान लो किसी की public key है 1@1, ये public key है. You pay at this. Who do you know you are paying? Right? जब वो अपनी private key से ये public key access कर सकता है and he can get his Bitcoin. You don't know who this person is. It's completely digital and it's completely anonymous. So he might be sending this to a terror organization later. Okay. Now you have to tell me, this is the question for today, the IR question, which organization helps curb terror finance in the world? Right? Which organization helps curb terror finance in the world? Ye batao. Very good. I'm not going to explain CBDC. Please read from economy. Good. FATF. Correct. Right. Okay. So in Bitcoin, what happens is, I'll now tell you the difference between private and public key. Okay. So let's say you have your private key and you have your public key. Public key is available and वो उससे लोग पे करते हैं. Now public key is a huge number. मतलब 18-20 डिजिट का नंबर होता है. ठीक है. तो अब क्या है, आप ऑब्वियसली इसको तो याद रखोगे नहीं. यू विल नॉट रिमेंबर 18-20 डिजिट्स एंड इट्स वेरी रैंडम, राइट? यू विल नॉट वांट टू कॉपी और कीप इट आल्सो बिकॉज किसी को पता चल गया एंड लाइक दिस इज, यू कांट रिमेंबर इट. सो व्हाट यू डू इज यू हैव अ प्राइवेट की. दिस यू कैन मेक बाय योरसेल्फ. ठीक है, प्राइवेट की है. प्राइवेट की को क्रिप्टोग्राफी करके पब्लिक की बनाया जाता है. पब्लिक की लोगों को दिखती है, लोग आपको यहाँ पे करते हैं, आपको सिर्फ प्राइवेट की याद रखनी है. दिस ओनली यू नो. व्हेन यू एंटर योर प्राइवेट की through the cryptography principle that you know, you can make the public key also. तो जो email address है वो भी आप मान लो, your email address is also sort of connected. Email address is sort of connected to your password. Because the email address is so weird and you can't remember it, you just remember the password. And password से ही you know the mathematical function that will lead to email. So if you have to make any change in your ledger, right? If you have to make any change in your ledger, if you have to do any transaction, if you have to receive any transaction, पैसे देने के लिए भी आपको अपना लेजर तो खोलना पड़ेगा, प्राइवेट की एंटर करनी पड़ेगी. So will you have to enter your private key? Once you enter your private key, your computer will derive your public key through this mathematical function. Then you will make your change. You will pay or receive money. Now, here this will create a digital signature. An idea, a digital identity or a digital identifier that yes, this private key was used. And yes, this some transaction has happened, right? So this will create a digital signature, a digital thumbprint, you can say, a digital thumbprint, because आपने अपनी private key use करी, तो digitally now that proof is available that you have used this private key to make certain changes, right? Now ये हमने देख लिया कि private key से आप अपनी public key derive कर सकते हो easily, right? But public key से nobody can get your private key. Public key सबके पास है, बट क्योंकि क्रिप्टोग्राफी है तो ये ऐसे नहीं हो सकता, बट हाँ इधर हो जाएगा, राइट? सो दिस इज अ मैथमेटिकल प्रिंसिपल कॉल्ड वन वे फंक्शन. डोंट नीड टू नो कि इधर से इधर तो जाना आसान है, बट इधर से इधर जाना मुश्किल नहीं है. इट्स वन वे ओनली दैट यू कैन गो प्रॉपर्ली, राइट? ओके, टू डिराइव दिस प्राइवेट की फ्रॉम समबडीज पब्लिक की, मान लो मुझे पब्लिक की आपने अपनी बता दी, मुझे इस पे पे कर देना, और मैं क्रिप्टोग्राफी से यहां पहुंच जाऊं, इसमें मुझे एस्ट्रोनॉमिकल टाइम चाहिए, टाइम लाइक लेट्स से आई नीड 10,000 years टू सॉल्व दिस प्रॉब्लम. ओके, आई होप कईयों को तो समझ आ गया होगा वेयर आई एम गोइंग विद दिस. नाउ a sure quantum algorithm, this term you don't need to remember, but a quantum computer, a large enough quantum computer can break this one-way function, because it can do what a supercomputer takes 10,000 years to do in 200 seconds. Right? So a large enough, powerful enough quantum computer can break this idea of going only from private to public and not the way back. तो क्या होगा, आप अपनी पब्लिक की शेयर करोगे कि मुझे इस पे बिटकॉइन दो, the quantum computer will derive your private key from there and then your account is gone. Right? So this large enough quantum computer, right, could be the problem for cryptocurrencies in the future. If quantum computers become everyday use, cryptocurrencies might lose their value. ये होगा या नहीं, it's very doubtful, right? But you know the idea. And क्यों नहीं होगा? Because you will need to know कि quantum computer उतनी तेज होगा, उससे फास्ट माइनिंग तो नहीं हो जाएगी, एक्सेट्रा एक्सेट्रा. Right. So in Bitcoin, there is private and public key. You use your private key, you validate your transaction, you generate a digital signature to spend your Bitcoin. Right? In a quantum computer, when you give the public key to people, that public key can be used to derive your private key, like somebody deriving your password from your email address, right? Because the computer is that powerful, right? So that could lead to a problem for cryptocurrencies, right? अब होता क्या है, मान लो मुझे किसी A को, A तो हमारी फिक्स ही है, A is आशिमा, right? आशिमा को, right, has to pay this person B. Right? तो आशिमा को B को बताना पड़ा, या let's say Ashima doesn't pay anybody, Ashima just wants money. So Ashima wants money from this person B. So Ashima says, here is my public key, okay, to Mr. B and pay me money. So then Mr. B says, fine, I'll pay you money. So till that time, the public key is publicly available, because जो माइन कर रहा है बंदा, जो ट्रांजैक्शन वैलिडेट कर रहा है, उसे क्या दिखेगा, that public key of Ashima has received this much money from public key of Mr. B. And यहाँ Ashima और B नहीं होगा, he will not see this. He will just see कि इस public key से इस public key पे पैसे गए हैं. He will not know who these people are. That is why there is complete anonymity. But till it is not mined, this public key is available. जब तक ये माइन नहीं होके ये ट्रांजैक्शन उस ब्लॉक में घुस नहीं गई है, तब तक ये पब्लिक की अवेलेबल है. मान लो कि 30 मिनट्स लगते हैं एक ट्रांजैक्शन को माइन करने में, तो 30 मिनट्स तक ये पब्लिक की विजिबल है. Until that time it is vulnerable to the quantum attack. Right? Now mining में क्या हो रहा है? There is a competition happening between the validators, between the people who are validating the transaction. At this time the quantum computer could say, okay, I have seen public key. Right? I have seen this thing, public key, and now from public key I will derive the private key. So during this time your account is vulnerable. Now अभी भी quantum computer है, but अभी क्या है कि current mining time of many transactions is 10 minutes. This is the maximum mining time, and the predicted time that the quantum computer at this stage, however fast we have it, at this stage it would take 30 minutes to 8 hours. 30 minutes to 8 hours to crack this public to private key. तो अभी right now cryptocurrency is safe. But if we make a quantum computer whose solving of public key to private key, solving of that opposite function is faster than the mining time, then quantum computing might affect cryptocurrency. Again, if you've not understood this, I will not explain this, I will not take any doubts on this, because you don't need to understand. The only thing you need to understand is quantum computers could be a problem for cryptocurrency, because they could solve the crypto in cryptocurrency. That's it. This crypto thing they might be able to solve, right? And the student who is Ashima, firstly, apologies to you, and you wrote this exact doubt, and that's great. That means you've really understood. Okay, now this completes our understanding of blockchain and crypto and our understanding of quantum computing. Now what we're going to do is we're going to read the applications of crypto. ठीक है, applications of blockchain, right? We're just going to understand how blockchain can be used in various different ways, not how blockchain works. एक basic idea blockchain का अगर आपको लग गया है तो I'll just tell you कि कल जो once we finish this internet and emerging technologies, computers, etc., I'll give you a one pager tomorrow that I'll discuss with you. उसमें जो जो पॉइंट्स लिखे होंगे आपको याद सिर्फ वही करने हैं. आज आपका काम सिर्फ समझना है. इफ यू आर अंडरस्टैंडिंग, और आप देखोगे बहुत क्वेश्चन आते हैं इससे. समटाइम्स दे लास्ट व्हाट पब्लिक की इंफ्रास्ट्रक्चर इज, समटाइम्स दे लास्ट व्हाट डिजिटल सिग्नेचर इज, समटाइम्स दे लास्ट ब्लॉकचेन डायरेक्टली. तो बहुत क्वेश्चंस आते हैं. So if you've just understood the terms, it will work for you. And वहां पे अगर आपको आइडिया हो तो आप उस टर्म्स को फिर उससे डराइव कर सकते हो, बिकॉज यूपीएससी नेवर यूजेस द लैंग्वेज वेयर वी स्टडी. आई डोंट नो हाउ दे फ्रेम इट, बट आपको कोई डायरेक्ट लैंग्वेज वो किसी बुक से डायरेक्टली नहीं मिलेगी. दे समहाउ चेंज द लैंग्वेज. तो रटने से बेटर है कि हमें कंसेप्ट पता हो. अब हमें कंसेप्ट पता है, हमें पब्लिक की का कंसेप्ट पता है, हमें प्राइवेट की का कंसेप्ट पता है. प्राइवेट की यूज करके जब हम चेंज करेंगे, ट्रांजैक्शन करेंगे तो डिजिटल सिग्नेचर होगा. ये चीज भी हमें पता है. राइट नाउ लेट्स सी सम ऑफ द implications of using blockchain differently. देखो अब बात, this is the concept of web 3.0. web 1.0, web 2.0 समझ जाएंगे, then we'll understand web 3.0. right, I hope it's clear so far. Just taking a minute. It's okay, I'm not, it's 2:30. I'll just teach for 10 more minutes, then you can take a leave. Those who have doubts, who want to talk to me, right, this is the last day I'm in my house, I'm comfortable in a seat, so आज हम बात करेंगे after 2:40. just give me 10 more minutes. okay, Web 1.0 is what? Web 1.0 is the static web. जैसे मैंने एक वेब पेज खोला, let's say I open the web, I see a web page and उस पे some information is written, right? Information, let's say, is written about the Taj Mahal. Okay, it is a static web page. If you open that web page, you will see the same information. If I open it, I will see the same information, right? Just information is there. The Taj Mahal, you know, it was built by Shah Jahan, it's in Agra, etc., etc. Okay, now second is web 2.0. web 2.0 is interactive web. what is interactive web mean? आप अभी खोलो facebook.com और मैं अभी खोलता हूं facebook.com, तो आपके लिए जो facebook.com होगा और मेरे लिए जो facebook.com होगा, they will be completely different, right? आप YouTube खोलो, मैं YouTube खोलूं, they will be completely different. So it is interacting. So it's not just that you are taking, if this is your phone and this is you, it's not that only you are seeing data here. Right? This way communication is also happening, right? So the phone also takes your data and you see what the phone shows you. जैसे आपने फोन को बताया कि I like cricket bats, I like cricket shoes, तो next time the phone will show you ads for cricket bats and cricket shoes. This targeted advertising, interactive internet is web 2.0 where we are right now. Okay, and I hope you understand कि इसमें there are huge problems, right? There are huge problems because, okay, tell me what the problems are. Yeah, chalo chodo yaar, we don't have time for this. The huge problems are, firstly, your data is not secure. Secondly, you are not giving consent. Facebook did not ask you, or it put the terms in such a way that you had to give consent to use Facebook, and then they are using your data to sell to advertisers, right? So what is the main problem here? You are the product, right? हमें लगता है हमें Facebook फ्री मिल रहा है. Okay, ये मैं आपको, let me just tell you this about economics and free things, right? If you are getting something for free, then it's not being sold to you, right? So you are the product. You are not the customer. The customer is one who pays for it. So who pays Facebook? Advertisers pay Facebook. So who is Facebook's customer? Facebook's customer is advertiser. So, and you are Facebook's product. What is Facebook selling to its advertiser? Facebook says on our platform, there are 1 million people active every second. So advertiser says, oh great, then I'll pay you this much to display my ads here. Okay. So what is Facebook's idea now? Facebook's incentive is to keep you hooked on social media as much as possible, because if there are 2 million people there every second, then it can get advertiser to pay even more. If there are 5 million people, Mark Zuckerberg will buy a private jet. Okay, now if he can keep you hooked for more and more time, they can make advertisers pay more. So you are the product. So what Facebook does is it actually employs addiction engineers that have engineered their platform in such a way that you stay addicted and you want to keep on scrolling, and it's very, very difficult for you to shut it down. So if you've started using Forest, great. If you've not and you can, I would recommend that from today, give up your phone. If you can't, you use Forest, but this is the best idea, because there are addiction engineers. There are people who are working to ensure that your time is spent here so that they get money from advertisers and you fail in UPSC because of this. Okay, try and give up your phone and at least give up social media from this point to the prelims if possible. Okay, आज का प्रवचन is complete. Okay, so in Web 2.0, you are the product. In Web 3.0, what happens is you design the internet. You put all the information that is there on the internet on blockchain, right? You put everything that's there on the internet on blockchain. So all data of the internet, rather than being in centralized servers of Google, centralized servers of Facebook, right? In these centralized servers, rather than that, it gets distributed in everybody's computers. So everybody owns the data, right? And the data is distributed. Let's see how it works. पहले हम थोड़े differences देख लेते हैं. Web 1 is like static web. Web 2 is it was stored on the cloud, the way Facebook does it. And Web 3 is blockchain distributed across multiple networks. What are the example of Web 1? Static web page, this we've seen. Web 2 is user generated content like social media. Web 3 has NFTs and cryptocurrency. NFT we'll understand today. Now, who owns the data? Here in Web 1, company. In Web 2, again, companies that host applications on cloud like Facebook and Google. And here no one owns the data, right? Or everyone owns the data. I'll show you what that means. Transaction, here no transaction is possible. Here payment gateways are there. And here transaction happens using the crypto tokens, right? You know what crypto tokens are? We've studied through cryptocurrency. Tabhi itna detail mein blockchain samjha raha tha, because now these terms become clear to you. Okay, all right. Ab dekho, Web 3.0 is like a big torrent network. If you know what this is, kudos to you. And ladkon ko samajh aa gaya hoga, I hope. But still, if you don't, I'll explain what this is, right? Okay. So what is happening is that data is stored over blockchain over many computers over the world. मतलब पूरे world में जितने computers internet use कर रहे हैं वो एक blockchain system है, और सारा ये data उनके computers पे store होता है. The way blockchain does it. इतना detail में समझने की जरूरत नहीं है. Just get the idea. Okay. जैसे there is a website called Odysee, right? You know what it does? Odysee does not have a central server like YouTube कि मैं अपनी वीडियो YouTube पे अपलोड करूं फिर आप उन YouTube के सर्वर पे वो वीडियो देखो. ऐसा नहीं है. वहां क्या सिस्टम है कि if you are a member of Odysee, you become a part of their blockchain. If you want to watch anything, it will be stored on your computer. You will own the data. You will get it on your computer. It will be stored on your computer. You will sort of download it and watch it here. So nothing can be taken down, right? Because there is no central authority. Everyone owns the data equally, right? And for watching and for making people watch, you get tokens, because the system grows because of that, right? Again, detail is not important. Odysee, they're not going to ask you. But what is happening is, it is an alternative to YouTube. Creators, right, they will earn library tokens for making others watch. How can you watch? Not on a central server like we do right now, but on distributed systems on your own computer through downloading, right? So everybody owns the data. If you want something, you can store it and nobody can take it down because there is no central authority, because it's working on the principle of blockchain. So the post is on many computers around the world because there is no central authority like in blockchain, and this cannot be taken down or censored. Okay, now who runs it? There is a DAO. DAO is a decentralized autonomous organization, right? Decentralized autonomous organization means there is no CEO. Who runs Web3? People who get the most tokens. People who have the most tokens, something similar to proof of stake. People who have the most tokens, they will take the decisions, and since the tokens will keep on changing, if you make a new video and it gets viral and many people download it, you'll get tokens for that. अब आपके tokens ज़्यादा हो गए, you can be part of the decision making process. So the organization is autonomous and the organization is decentralized. So there are DAOs that are going to run Web3. I know ये बहुत detailed और difficult हो रहा है. Web3 पे UPSC ने question भी पूछा था last year. If you just know blockchain के principles and that you're running the internet on the blockchain in a decentralized manner, decentralized तरीके से इंटरनेट चल रहा है ब्लॉकचेन पे, सबके पास डेटा है, किसी एक बंदे के पास नहीं है, राइट, एंड एवरीबडी इज द ओनर, देयर इज नो सेंट्रल अथॉरिटी. आई थिंक इतने से आपको क्लियर हो जाएगा, राइट. दिस इज ऑल दैट्स नीडेड टू अंडरस्टैंड. ओके, व्हाट इज द कोर टेनेट इज डिसेंट्रलाइजेशन. सो मल्टीपल लोकेशंस पे, जैसे ब्लॉकचेन में सारी इंफॉर्मेशन हर बंदे के पास स्टोर होती थी, यहाँ इंटरनेट की सारी इंफॉर्मेशन हमने वहां स्टोर कर ली, राइट. तो मेटा और गूगल जैसे जो इंटरनेट जायंट्स हैं वो खत्म हो जाएंगे, राइट, बिकॉज देयर इज नो पर्टिकुलर सेंट्रल लोकेशन, एवरीबडी हैज द इंफॉर्मेशन. नाउ देयर इज नो सेंट्रल अथॉरिटी. तो अगर आपने कोई हेटफुल कंटेंट डाल दिया, कोई रेसिस्ट कंटेंट डाल दिया, तो आपको कोई कह नहीं सकता कि यू नीड टू टेक दिस डाउन, राइट. नोबडी इज गोइंग टू से दैट टू यू. यू हैव टू, लाइक, इट विल बी देयर. दिस इज अ प्रॉब्लम. There will be greater control to the user. Your data will be secure. Nobody is going to steal your data because it will be on your own computer. It will be trustless and permissionless. What does this mean? Trustless means that network will allow the participants to interact directly without going through a trusted intermediary. You can directly interact. आपके कंप्यूटर पे भी सारा information है, right? So you don't need to go through an intermediary or a central authority like Facebook to interact between two people. And permissionless means that anyone can participate without authorization from a governing body. Basically वही मतलब है कि कोई central authority नहीं है. It is decentralized. Everybody's computer has the information, right? And it's not done yet. This is just the beginning of Web 3.0, right? So this is what the idea is. Now the apps also are decentralized, right? So they are built on blockchains. They are built on everybody's computer. So they are called decentralized apps. The finance is also decentralized, right? Because the transactions will not happen through a central authority but through finance, and this means decentralized finance. Then there are DAOs. DAOs are decentralized autonomous organizations. Who controls them? Persons who have the most tokens. So DAOs, that means even the governance structure is decentralized. So the technical system is decentralized, the financial system is decentralized, the governance is decentralized, no central authority. This is what Web 3.0 is. Okay, it will be integrated with AI and ML, and how that we'll see tomorrow. Okay, now what are the problems? First, always consensus will have to be established, right? So if consensus has to be established, the decisions will be slow. जिसके पास tokens हैं वो सारे मिलके they have to decide, so decisions will be slow. Data privacy issue, why? Because of the hateful content that is there and the malified use that's possible and the hacking of your computer. Not that the central authority will take your data, but somebody can take your computer. That is the problem. It is not decentralized, right? And then the rest you can read. Whatever the issues of cryptocurrency are there, wo to isme hai, right? So this is Web 3.0. Just a basic idea. It is putting the internet on a blockchain. This is what Web 3.0 is. Okay, so whatever ideas of blockchain were there, you apply it to the internet, of decentralization of apps, decentralization of finance, decentralization of the governance structure through autonomous organizations. Okay, now let us understand the last concept for today, non-fungible tokens. Okay, non-fungible tokens are digital identifiers. So this is like a certificate of ownership for a digital asset. Okay, certificate of ownership for a digital asset. Its market has grown exponentially. Okay, in recently there is an artist called Pak, not related with Pakistan. He had made a work called Merge. The picture that he had called was called Merge. It showed the merging of the first few galaxies. This through a NFT was sold for $91 million. Okay, so this is what NFTs are. They are digital identifiers or certificate of ownerships. How they work, I'll tell you. But before that, what you tell me is what is fungibility. This you have to read in economy. What fungibility is. So fungibility means subdivision into units and mutual substitution. For example, if there is a rupees 2000 note, right, you can divide it into subunits. 4 subunits are possible, right? And mutual, this is first is division. This is the first criteria. Second is mutual substitution, that this and this, right, they have the same value. 4 notes of 500 or 1 note of 2000, same value. So this is mutual substitution. Fungibility is subdivision and mutual substitution. This you have to read in economy also, right? Okay. Now in other cases are, let's say there is a 1 kg gold bar, right? This is divisible, yes, and mutually substitution is also possible. But let's say in a 100-gram diamond, you can divide it into 100 diamonds of 1 gram each, but it is not mutually substitution possible because इसकी वैल्यू बहुत कम होगी एज कंपेयर टू द होल डायमंड. बड़े डायमंड की वैल्यू बहुत ज्यादा है, छोटे छोटे डायमंड्स की उतनी वैल्यू नहीं होगी. सो दिस इज नॉट अ फंजिबल आइटम. 1 kg gold bar is 100% fungible item because 1 kg gold bar is same as 100 gram gold bars. ठीक है, so there is two things, subdivision and mutual substitution. In non-fungible token means that basically subdivision and mutual substitution cannot happen. This is the idea of non-fungible tokens. देखो NFT क्या है? It is a digital file stored using blockchain. Blockchain is used in its backend. ठीक है, that is why understanding blockchain was important. How it works I'll show you. Now this file cannot be subdivided, subunits cannot be exchanged, right? Because values are different on the basis of the buyer's preference, right? So NFTs are non-fungible. All right, it is a digital file stored using blockchain and NFT is a digital identifier. How it works, let me show you. देखो, मान लो यहां पर मैं अभी एक इमेज बनाता हूं कैट की, ठीक है. I make this image of a cat. Now let's say this image becomes viral and many people copy this cat. ठीक है, सबने क्या किया कि सबने इस कैट को कॉपी करना स्टार्ट कर दिया and now 1 million copies of this cat are there on the internet and on your, or 1 lakh copies are there, it's on your phone. सबने अपने फोन पे यही वॉलपेपर लगा लिया. It became so popular that you know Shivan has drawn this cat, it's the best cat ever. Okay, now right, this is the original image. अगर आप इसे कॉपी करोगे इट विल स्टिल लुक द सेम, इट विल ऑलवेज लुक द सेम, राइट? बट हाउ कैन यू से दैट दिस वाज द फर्स्ट इमेज दैट वाज ड्रॉन, द ओरिजिनल? ये तो आप कभी भी नहीं बता पाओगे डिजिटली, राइट? यू विल नेवर बी एबल टू से दैट दिस इज द डिजिटल, द ओरिजिनल वन, राइट? बिकॉज इफ इट गेट्स कॉपीड इट विल लुक द सेम. सो व्हाट एन NFT does is it places a digital frame around the original image. एक और तरह से समझाता हूं. Let's say this is the shirt, right? This is a shirt that Van Heusen has made. Okay, now is it a Van Heusen shirt? No, it's not a Van Heusen shirt. Okay, so let's say this is a shirt that Van Heusen has made. Okay, now Van Heusen makes many of these shirts, right? But let's say this was the first shirt and every other was a copy of this shirt. इस shirt को copy करके फिर उन्होंने बाकी बनाई. आपको difference पता नहीं चलेगा, but मुझे यही वाली चाहिए. I want this one which was the exact first one. Okay, जिससे बाकी सारी बनी है. This cat which is the exact first one. So what I'll do is I'll make a frame around this. Right? I'll make a digital frame around the first ever thing to show that I own it. This digital frame or this certificate of ownership around the original item is called the non-fungible token. Now why is it a token? Because it is based on token based economics जो हमने देख लिए हैं blockchain में how they work, right? And why is it non-fungible? It is non-fungible because it is unique. Since it is the first one, it makes it unique. Now it is not mutually substitution possible for other cats like this. Even if the image is the same, this will always remain the first one. Even if on looking at it, on screenshotting it, on copying it, you cannot tell the difference, but you will know that this is the original first one. This is what an NFT is. Okay, I'll just stop here today. I'll just explain a little bit about this tomorrow. I know थोड़े concepts आज ज़्यादा हो गए होंगे. So I'll just stop here today with the explanations. Those who want to take a leave, they can take a leave. अगर नहीं समझ आया NFT, we'll discuss NFT a little bit tomorrow and then we'll see the rest of the technologies. कोई खास टेक्नोलॉजी रह नहीं गई है. Only thing that will take some time to understand is Li-Fi. Everything else is pretty clear जो हमारा रहता है अब. Okay, so you can take a leave now. Tomorrow we'll do internet and the remaining emerging technologies, and on Saturday we'll do IPR and role of scientists. All right, thank you, and now I'll see your questions and comments. Thank you. One pager tomorrow. One pager for today's class tomorrow. I'll revise it with you. जो उसमें लिखा होगा जब हम टॉपिक खत्म कर लेंगे तभी वन पेजर देने का फायदा है. बीच में फिर मुझे अपडेट करना पड़ता है. Thank you for your patient listening. I know it must have been hard. I tried to make it as simple as possible. Thank you, Aisha. Thank you for joining regularly. Yes, Tarun, it is a copycat. 2 मिनट रुक जाते हैं यार, 2 मिनट में I'll get to your questions. Yes, Akshay will do nuclear energy with environment because I want you to understand renewable energy together. Mohammed Mehmadul Hassan, NFT is complete, nothing else is required. If you've understood this much is enough. कल थोड़ा सा मैं और आपको बस डिटेल में समझा दूंगा, इससे ज़्यादा कुछ नहीं है, it's just a digital identifier. That's all it is. Thank you. Piyush, how do I concentrate this long? I used to study 12 hours daily. This is a joke. Digital signature कल बताएंगे ना गणेश, बेसिक तो आ ही गया है. Books that you read beyond UPSC. Personal questions can be sent on Instagram, not here. This is not the platform where I should answer personal things. Kanika, go to your convocation. See the class recorded. Today I came across a course that they will teach some rules to get 130 plus in prelims. Sorry. Karthik, obviously they're not reliable, yaar. I mean, how can someone just teach you to get 130 plus? You need knowledge, okay? Energy we will do with environment. Shambhavi, yes, I did learn all of them on my own. I took a lot of time. I enjoyed this actually. Thank you, Trippy. Nice name. Thank you, Mahi. Thank you, Aisha. देखो यार, geography, the concepts of physical geography, right? That I can't do here. Okay. Mapping में I will only do the national parks, tiger reserves, biosphere reserves, whatever is environment related. For example, I'm not going to draw a map of rivers. I will draw a map of rivers. I will expect you to know where rivers are generally. Then I'll show you which river goes through which national park. Okay, तो आपको एक बेसिक आइडिया होना चाहिए, बाकी मैं कराता हूँ, राइट? और इतनी कोई बहुत इंटीग्रेशन है नहीं ज्योग्राफी उसकी. हाँ, थोड़ी क्लाइमेटिक रीजन्स की इंटीग्रेशन है, दैट आई विल डू. नेहा, वेरी वेलकम. Akash, Objective Indian Polity by Lakshmikant. Yes, it's good. Abhijit, we'll do digital signature tomorrow. Oh, Banu, so sweet of you, but I'll go tomorrow to the studio. Are you done? Kaushal. The cat is not going anywhere. Cat is still there. NFT is just a frame. Harshit, thank you. I'll do something for economy next year. Asha, Ergosphere, you should read from geography. Yeah, just Nishu, I think it should not be a problem. Just read them once. It's not should not be an issue. उसमें कुछ नहीं है. Just remember what is written there. Sir Shankar करे कि नहीं. Mapping notes. I'll do the environment mapping part. I don't have consolidated notes for other part of mapping. IR, when I do on YouTube, then I'll do the world mapping thing that's there in the IR PT365. Environment book, Shankar or PMF, nothing, just my class. क्या sectional अब लगाने चाहिए? Maybe 1 or 2, but not on Sundays. Sundays focus on full length. Gautam Surya, you're very welcome. Shubh, करेंगे discuss. Sachit on Saturday. No, Quantum is not doing mining. Quantum is cracking from public to private key. Quantum wasn't doing mining there. Quantum was trying to understand जो public key shared है उससे what the actual private key is. If Quantum does mining, it will do it in 1 second. Understand what I'm saying? Quantum wasn't doing mining there. It was doing something much more difficult. एक बार आप slides दोबारा देखना, सब लिखा हुआ है, you'll understand. Yes, Karthike. Sir, I did my ANC but unable to. Lucent करो यार, and if you're just able to do the basics, Shubham, that would be fine. Shivi, timing of environment I'll tell you because there'll be some issues in the studio. I think some other classes are also starting there. कल बताता हूँ यार मैं टाइमिंग, मैं वहाँ चला जाऊँ एक बार. No, it's not similar to YouTube. Now you don't have to log in, Piyush. In Odyssey, you don't have to log in anywhere to see, or you don't have to make an account. Just become a part of their network, store the data on your computer and see it. There's no place like this. 12 hours like me, you want to study Vikas. देखो forest choose करो, and if not forest, rather I'd expect you to give up your phone. And it's actually how many hours you study in a day. It all comes down to what you do in your breaks. Okay, if you take your breaks well, right, and in the break, if you are focused on things that are not taxing your mind, let's say you are taking a nap, or you're going to a walk, or you're talking to a friend, that would be great, right? That is the best break actually. So if you take breaks well, you will be able to sustain longer. What happens is, in our break, we tend to watch television or look at videos, and they tend to make our mind even more stressed or more worked. So we don't feel like coming back. Break अच्छे से लोगे तो बढ़िया काम होगा. No, Narendra, I'll do it. Done. Ari, I think, yeah, I cannot tell you. I'm not the UPSC examiner, but I think if past trends are anything to go, not less than 25. God particle will tell you later. Not that important, you can forget it. It's the particle that when I explain dark matter, I'll tell you it's the particle that explains the universe. Swapnil, concentration issues. How did I give up my phone? Sambhavi. Okay, I'll first take Swapnil's question. Swapnil, concentration issues, say I don't understand anything. So you'll have to tell me what exact issue you're facing, right? And I've got a lot of questions like this. So I'm not been able to make YouTube videos because I'm not feeling very well. That also takes a lot of effort. I'll try and make one today, but I'll just write this, and I'll make one video on this. Okay. Anshu, do pillar 1, pillar 2, pillar 3, pillar 4, 5, 6, just do the Win series. Shambhavi, I did not have a phone for 2 years. I had that small Nokia Asha 200 for 2 years. I was a Samsung Guru, but same thing. For 2 years, I did not use it. It could be. I mean, I cannot predict. How many hours video would be IRPD65? Can't say yaar. Agar tumhe itna tension ho raha hai, then you do it on your own, because I can't make claims like that. No, Nishu, you try. You get those wrong. Kripa, if you have time, then it's better to see videos. Economy is complex, and Mrinal sir's notes won't do enough for mains actually. Sandeep, I've only used Vision or Forum. Out of those two, I'll say Vision. Aditya, I'm from Gurgaon. Payesh, or please, no personal questions not here. I'm sorry, I answered that. Personal questions are, you put them on Instagram, and ideally none of you should be using Instagram. Payesh, maths for CSAT, myself bad at it, can't give a suggestion. Economy PYQ, I'm able to solve questions with 80 to 90% accuracy, scoring around 60 to 70. Leave it यार, छोड़ो विजन के. अगर economy के PYQ हो रहे हैं तो this is fine. How much we need to cover for world mapping? See, there's no right answer, but there are certain regions in the world that need to be done well. So you need to do the Middle East well, Mediterranean well, South China Sea this year very important, Russia Ukraine region, Black Sea, Sevastopol port, Strait of Bosphorus, Marmara Strait, what is the Dardanelles Strait, the Montreux Convention, all of that, right? Then how the Mediterranean, Aegean Seas, Ionian Sea, and all of that, the coast of Croatia, etc. Do that well. Then South China Sea, Luzon Strait, Taiwan Strait, Nine Dash Line, Gulf of Tonkin, do that well. Then other than that, of course, around India, whatever is close, wherever the string of pearls are, that you have to do well. Then in the Middle East, Strait of Hormuz, Gulf of Aqaba, Red Sea, Bab Mandab Strait, etc. Do that well. So Middle East, Mediterranean, South China Sea, these regions, and this year Europe and Dnieper River, and how Kyiv is split into two parts by the Dnieper, etc. Those things you do well, and the other you can just take a look once of all the continents. Thank you, Vikas. So nice of you. Thank you, Swapnil. तेजस आज बनाता हूँ यार स्ट्रैटेजी वीडियो ऑन सी सेट. नो अंकिता, यू कीप डूइंग द रिविजन. देखो नेम्स पे उतने क्वेश्चन नहीं आते, इवेंट्स पे ज्यादा आते हैं. Sonal, I haven't seen at Sathi's notes for economy, so I'll just check and then tell you. Adiba will do something for means for sure. डार्क वेब कल बताएंगे. लूशियस क्यों हो रहा है इम्पोस्टर सिंड्रोम? अभी तो प्रीलिम्स भी नहीं निकाला. प्रीलिम्स निकाल के हो तो फिर तो समझ भी आता है. हेल्थ एंड वेलनेस सेंटर्स आर अपग्रेडेड वर्जन्स ऑफ PHCs. हाउ टू फिक्स इंसोम्निया? ओके, देखो यार, if it is not psychological, if it's psychological, I cannot give you a solution right now. Do this and you'll be able to sleep. For that, you would probably need to go see a counselor. But what you can try is, the masturbation generally works. Okay, but if it's not working, and it's not very healthy, by the way, it's not healthy to rely on that for sleeping. So I would recommend you see somebody. If it's really that bad, you should go see somebody. It's not possible for me to give a solution out like this. Don't medicate, please, especially at this stage, and it will become a problem. It will be a more of a problem later, right? So I would recommend you go see somewhere. यार इतना conceptual ना आता नहीं है शुभम, so that's okay if you just remember they mostly ask facts and explanations. Sir, I have attended Mrinal sir PCB5 batch. यार ये तो आई डोंट नो, ये मृणाल सर ही बताएंगे यार. बट PT365 कर लिया है, फिर Win23 मत करो. वीकली वर्किंग, इफ योर जॉब is, let's say, 8 to 9 hours on from Monday to Saturday, right? So I would say then 35 hours a week. Can I give prelims PYQ as mock test? No, give coaching mock test आपको आता होंगे. Yes, Sandeep. Yes, Rahim. Suresh, I would need to know the reasons why you're getting this less. And we'll do live sessions after 20th on YouTube. We'll address these questions there. तब I know actually कि 20th April के बाद ही आप लोगों का सबसे ज़्यादा एंग्जाइटी बढ़ेगा, तब तक कोर्स खत्म हो गया होगा. तो YouTube पे ना we'll do some regular live sessions where I just sit like this and talk to you, because I know उस टाइम पे कितनी ज़रूरत होती है. Somebody would just come and assure you. Nothing else is required actually. You've done well, if you've studied hard the entire year, you're all set. But there's nobody in the end there to help you connect and talk to you and just tell you that it's going to be okay. And that's what I'm going to do for you. So don't worry about that. Okay, Rameshri, I'll look into this. Yeah, please don't send your questions twice or thrice. What that does is I'm not able to read the other ones. I'll try and get to everything, but you also then get an idea. I'm not naming anybody, just get an idea. Don't send the same thing twice or thrice. Okay. Sambhavi, personal questions on Instagram, please. And I'm not guaranteeing that I'll reply. I don't check it all the time. How many tests before prelims? I've already dealt with this. Sanskriti, do we have to read Bio NCRT 4 chapters before the environment classes? No. If you read it, then what will I read? TKR Sampath, Science and Tech is going to finish on Saturday. Environment is going to finish on 20th April. Prashant, good yaar. Thank you for this initiative. This would be great. Suruchi, well, we're making a test for you. Karthik, I'll make it today, yaar. Swapnil, yes, it is mandatory. And how it's to be done, I'll tell you. Don't do it right now. I'll tell you how it's to be done. Aisha, thank you so much. Rahim, अरे रिजल्ट तो आ जाए यार, बस पार्टी ले लेना तुम. Yes, Ari. अनीशा आएंगे ना एनवायरनमेंट में, क्यों टेंशन ले रहे हो? I have a diploma in international relations from the Indian Institute of Governance and Leadership. So I've never actually studied IR for UPSC at all, not even once. Is 123 series enough? Yes. For agriculture, do geography well यार. एक बार आया था 2020 में agriculture. अब can't know everybody. Himanshu, that's long COVID. Go see a neurologist once यार. Optional was anthropology. Okay, Tarun. Your name is GS Core. Okay. She said I'll make a video today. Mining doesn't help in quantum computing. Yeah, go read the slide once. How much time does it take to create this many slides? I sleep for 7 hours. Other than that, I'm always working. Geography NCRT enough? Yes. For human geography, yes. NCRT is enough for human geography, nothing more. Yes, Jitinder, use forest. Nitin, I use the iPad, I use forest, I also use flashcards. Vaibhav, no, I haven't taken Vision Abhyas ever. Yes, Gaurav, it's fine. अरे I'll give it यार, थोड़ा relax, chill करो. जब कह रहे हैं करवा देंगे तो करा देंगे ना. Tarun, write down whatever you need to search and search it only at the end of your session. If you start using internet while studying, it's going to be very annoying. Thank you, Shubham. Thank you, Gurleen. Saket, right now for prelims you can only do the NCRT, nothing else. डर लग रहा है आयुष, देखो यार डर तो लगेगा ही. Can't do much about it. Rishin, because I like international relations. She said I'll make a video today. Ishita 17, it's a good score. Yes, Rahim, they're good. Thank you, Ishita. You just send personal messages on Instagram, yaar. This distracts me. Okay. Keep track of ancient medieval art and culture terms to write it in one place, yaar. Sankhonil, I've heard they're good, but I've given only one or two. I've mainly given Vision or Forum only, so I can't tell you yes or no either way. Anthro, because I thought के number आ जाएंगे. Physical geography NCRT. Sandeep, what is this? What does physical geography NCRT mean? Ask a question at least. Any possibility of mentorship? I'll do mentorship for free after 20th April. No? We'll just connect on YouTube. Otherwise, other than that, it won't be possible for me. I want to take a break for myself also for some time. You know, it's been very difficult. Past 2 months, past 2 years, I've not taken time out for myself. So I'll take some time out for myself. If not Abhyas, then what? Forum Simulator. Samata, I've already made a video on this on my YouTube. So you can go check that out. Rajesh Anki, I'll tell you when mains comes, not useful for prelims. Yes, Anthro, I'll do it. Shubham, bas ho gaya hai aate aate. Yes, Nikita, I'll teach. Okay, Vaibhav. Okay. Thank you, Shubh. Thank you, Ravin. नहीं, अरे मैंने नीट दिया था, I'm not J. All right. So we're done for today. It's 3 p.m. So now I'll see you tomorrow, same time, 12 noon. Tomorrow, hopefully in the studio. Hopefully, yeah, I'll try my best to reach the studio. We'll finish emerging technologies tomorrow, do a test of emerging technologies and computers tomorrow, then do role of scientists and IPR on Saturday. All right, thank you for joining in. See you next time.